Assalamu alaikum, everyone. Can everyone hear me loud and clear right now?
Yes.
Okay, perfect. So we are going to start our session in few minutes. Okay. We are waiting for other participants to join us as well, and then we are going to start it. Okay. Just wait for a few minutes. Are you from? Okay. Aisha, can you unmute yourself as well? Okay, let me make you co-host and rename yourself. Yes. Are you there, Aisha?
Yeah, I am.
Okay. Okay, perfect. So we have some participants over here. We are waiting for other participants to join us, and we are about to begin our session for today. So are you guys excited to attend this workshop? What do you know about James Webb Telescope or about space? You can write down in the chat box. आप लोग chat box में लिख सकते हैं. My name is Rayan Khan. I'm gonna introduce myself later on as well. We have Aisha Mubarak Ali. She is co-founder of Cosmic Tribe and also art director and visual artist. And we will be joined by NASA Solar Ambassador. And just give me 1 minute. I'm gonna it will be a little distracting for me as well. You can keep your cameras off. Maybe later on you can turn it on. Aisha, are you there? You can.
Yeah, I am. Should I on my camera?
Okay. Yes, you can turn on your camera, so it will be a good two-way communication with me and you, and later on. Okay, perfect. So here we have Miss Aisha with us. She is going to introduce herself. Yes, Aisha. Yes, go ahead, please. आप बताइए अपने बारे में थोड़ा सा.
Okay, are we waiting
Yes,
for Todd or should I just start?
We are going to start just.
Okay.
Yes, please go ahead.
So my name is Aisha. I'm a co-founder of Cosmic Tribe with Rayan, and we've been working for Cosmic Tribe a lot of activities related to space, related to art. But if I give my own personal introduction, then I'm a visual tech artist. I work in the domain of digital art. Recently, I've been into a lot of fusion techniques because previously I have done a lot of costume design projects. So now I'm in that phase where I'm more focused on digital art projects, and my techniques involves digital art. It involves fusion works. It involves different methods in which AI, artificial intelligence, and obviously I'll be talking more about it, that can be integrated. Other than that, I've been working on design projects for Oshi Brownie, and I also work as a creative director there, basically as a creative director. So, Oshi Brownie is a platform where we also work with fusion aesthetics and we combine costumes, and it's a design startup. So that is my side thing. Other than that, today I'll be talking more about space dynamics, space art, cosmic art, and what we've been doing with Cosmic Tribe. Yeah. So I'm so glad to be here, and let's see.
Okay. So first, I'm gonna. Yes. Thank you, Ms. Aisha, for having us and join this forum with us. So let me open this. What I say, there is a poll that I'm going to launch, and you need to give the answer. There are some questionnaire as well over here. I want to see कि आप लोग कौन हैं और कहाँ से join कर रहे हैं और कौन सा आपका age group है, आप लोग कौन सी class में हैं. Please give the answer. choose the best option and give the answer, so it will be easier for me to pick the right options. So yes. Okay, we have students from secondary grade. The age group is between 10 to 16, and we have they know about the orbit. Okay, interesting. A lot of people know the orbit. Okay, of the James Webb Space Telescope. अभी तक मुझे सिर्फ 3 लोगों ने आंसर दिया है. I want जितने भी ये 21 participants हैं इस रूम में, वो सब इसका आंसर दीजिए. And then okay, we have some smaller audience as well. So from 6 to 10 age group is here as well. And from secondary grade, okay, interesting. I think I need to wait for more. 1 more minute, because only 9 participants gave the answer. Rest of you, please give the answer as well. Okay. So few more seconds. And I think I'm just gonna stop because no one is answering anymore. So here are the results, as you can see on the screen. आपके पास एक स्क्रीन पे रिजल्ट आया होगा कि कौन से पार्टिसिपेंट्स कहां से और कौन सा उनका एज ग्रुप है, कहां से ज्वाइन कर रहे हैं. You can write down in the chat box as well. If you have any question, if you want to write down something, you can write down in the chat box. We will entertain your questionnaire if you're raising your hand later on after the session, like after finishing my talk, and then I'm going to accommodate you. If you have any urgent question to talk about, you can write down in the chat box. So let's begin with our talk for today. First of all, आप लोग को यकीनन ये मालूम होगा कि जो आप लोग का आर्टवर्क है, जो आप लोग जेम्स वेब टेलीस्कोप से इंस्पायर्ड आर्टवर्क बनाएंगे, इट इज गोइंग टू बी डिस्प्लेड एट आर्ट गैलरी, जो कि आर्ट गैलरी फुल सर्कल गैलरी विच इज इन कराची, क्लिफ्टन कराची. वहां पे जो है 18th को आपका आर्टवर्क डिस्प्ले किया जाएगा. आई वांट यू ऑल टू पार्टिसिपेट एक्टिवली इन दिस एक्टिविटी. आप लोग सब लोग काफी सारा आर्टवर्क बनाइए, लेकिन इन आर्टवर्क बनाने से पहले आप लोगों ने ये भी सीखना है कि how does this James Webb Telescope work and what is in space. So I hope to see you all on 18th, and as well as I'm going to talk about myself. I'm founder of Cosmic Tribe. I'm also International Astronomical Union Dark Skies Ambassador, which is on that platform I am advocating for the night sky. कि नाइट स्काई कैसा होता है और लाइट पोल्यूशन से होने वाले इफेक्ट हमारी हेल्थ और एनवायरनमेंट पे क्या होते हैं. Yes, okay. Other than that, I'm also Young Persons Committee Head of Royal Aeronautical Society Pakistan Division. I'm also National Astronomy Education Coordinator. I've done my master's degree in astrophysics. I also have aircraft maintenance engineering license. ये आप लोगों को आगे चल के मैं बताऊंगा कि what is in space. आज का जो हमारा टॉपिक है, that is, my talk is all about Earth to Infinity, and we will unfold the universe today. This event is free for all. Anyone can join us above 10 age. जो 10 साल से ऊपर हैं वो हमें join कर सकते हैं. किसी को भी आप Zoom link share कीजिए. They can join us and be a part of this workshop. I'm going to talk about Earth to Infinity, unfold the universe with James Webb Space Telescope. We will be joined by NASA Solar Ambassador Todd. So he is going to talk about piece of the discovery, personal journey. It's going to be very interesting talk. And we have Aisha, जिनसे आपका introduction अभी हो चुका है. She is going to talk about NFT and digital art as well. And later on, we are going to have some art activities, and I'm going to talk about James Webb Telescope and related to art activities, जो कि किस तरह का आप लोग artwork बना सकते हैं. So this is our day first. In day 2, what we are going to do? In day 2, we are going to have a physical workshop. मैंने कुछ आप लोगों के लिए कुछ printing की है, और ये जो है 3D James Webb Telescope design models हैं, जो हम लोगों को कल आर्ट गैलरी में सबसे पहले ज्वाइन करेगा. They will get a chance to design these मॉडल्स लाइव विद अस, हम लोग के साथ मिलके ये आर्ट वर्क करेगा। और ये सारा आर्ट वर्क जो आप लोग पेपर पे भी आर्ट वर्क करेंगे, आई वुड लाइक यू ऑल कि आप सब लोग जो है अपने आर्ट वर्क अपने घर पे भी बनाइए और पेपर्स पे बनाइए, कैनवस पे बनाइए, एनीथिंग। आयशा इज गोइंग टू टॉक अबाउट कि किस किस किस्म का आर्ट हो सकता है, मतलब पेपर, क्लोथ, एनी रिसाइकल मटेरियल, plastic bottles, anything you can use for the art. And other than that, on 18th आपकी जो सबमिशन डेट है वो 17th है। 17th मतलब कल आप लोगों ने सारा आर्ट वर्क जो है हम लोग को सबमिट करना है as soon as possible. So it is going to be so much fun. आप लोगों को का जो आर्ट वर्क होगा वो काफी सारे लोग देखने इसको आएंगे. So keep this in mind. Your participation is so important for us. इन सारी चीजों के अलावा जो हमारा जेम्स वेब टेलीस्कोप का आर्ट वर्क डिस्प्ले है वो 18th को मींस सैटरडे वी हैव दिस आर्ट वर्क डिस्प्ले, जिसमें आप लोग जो है, ओके ज़ैनब इज हियर एज वेल. Interesting. Zainab is also part of Cosmic Drive and she is joining us as well. So thank you, Zainab. I'll introduce you as well and we can be on board and talk about it. अभी जो है right now I'm gonna finish this part and on 18th जो हमारा आर्ट वर्क होगा वो डिस्प्ले किया जाएगा. टाइमिंग इज 5 to 8 p.m. Visitors from your family, anyone can visit the art gallery between this time. इससे पहले 4 p.m. से पहले I must say कि अगर कल नहीं कर सकते तो परसों 4 p.m. से पहले हमारा ये जो डिस्प्ले है वो सारा अरेंज हो चुका होगा. So please submit your artwork on time. आप लोग अपना आर्टवर्क जो है please submit them on time. So let me move to the next slide. Let's talk about Earth to the infinity, what it is, and unfold the universe. So सबसे पहले when we talk about the solar system, जिसमें आप लोग को यकीनन मालूम होगा कि there are 8 planets and their names, and beyond this where we live in Milky Way Galaxy. And then as you can see here is a complete universe. और ये जो आप लास्ट वाली पिक्चर देख रहे हैं यूनिवर्स में, you are not looking at the stars but you are looking at the galaxies actually. यहाँ पे जो है आप लोग को गैलेक्सीज दिख रही हैं, इतनी सारी गैलेक्सीज हैं. हमारा सोलर सिस्टम इज जस्ट अ बिगनिंग ऑफ द यूनिवर्स. सो व्हाट इज एस्ट्रोनॉमिकल यूनिट? अब कैसे मेजर किया जाता है एस्ट्रोनॉमिकल यूनिट को? कितना डिस्टेंस होता है और ये लाइट ईयर होता क्या है? क्योंकि हम लोग जो स्काई में ऑब्जेक्ट होते हैं वो एस्ट्रोनॉमिकल यूनिट में मेजर करते हैं. और क्या आप लोगों को मालूम है व्हाट इज एस्ट्रोनॉमिकल यूनिट? ये होता क्या है कि एक, फॉर एग्जांपल, as you can see in this picture right now, one astronomical unit is equals to 149.6 million kilometer, जो कि एक light year के बराबर है. So when we talk about this, let me move to the next part. One light year distance is the distance light travel in 1 year at a speed of light which is 300,000 kilometers, which is a lot. इस स्पीड से जो है जो हमें स्टार्स दिख रहे होते हैं, if for example if a star is one light year away, just for an example, it means जो हमारे पास लाइट आ रही है वो 1 साल पुरानी है, 1 light year distance पे मौजूद है. You get it? कि हमारा जो पास्ट है वो हमें स्काई में दिख रहा होता है अगर हमें स्टार्स सारे दिख जाएं. So there are billions and billions of stars. There is a minor calculation if you are interested to learn about this calculation के किस तरह से जो है लाइट ईयर को सेकंड्स में, मिनट्स में, आवर्स में, डेज में डिवाइड करके we will get the total number of kilometers. कितने किलोमीटर डिस्टेंस होता है one light year. So as you can see, 1 light year is equals to a big number actually. So which is approximately equals to 10,000 billion kilometers. 10,000 billion kilometers, which is a very long distance. Let's talk about parallax. ये parallax होता क्या है? Anyone can give me the answer in the chat box? Anyone would like to say anything? Yes, sir. Okay. Anyone? What is parallax? आप लोगों को से एक सबसे बेसिक सा एक्सपेरिमेंट करने को मैं बोलता हूँ. Put your thumbs like this and close your one eye. Try to close it And now open the left eye and notice your thumb is actually shifting from one point to another point. This is a very basic technique through which you can actually measure कि stars जो हैं वो किस तरह से जो है मूव कर रहे हैं, या हमारे जो ऑब्जेक्ट्स हैं उनका डिस्टेंस क्या है. सबसे इंपॉर्टेंट चीज, लाइट ईयर डिस्टेंस को कैलकुलेशन किस तरह से की जाती है, उसकी मेजरमेंट पैरालैक्स के थ्रू होती है. लाइट ईयर डिस्टेंस की मेजरमेंट स्टार्स की एक्चुअली जो हमारे लाइन ऑफ साइट में फॉर एग्जांपल स्टार्स हमें दिख रहे हैं, एज यू कैन सी हियर इन दिस पिक्चर राइट नाउ. अर्थ जो है जून में एक जगह पे था, और क्योंकि हम लोग अपने आंखों को बंद और खोल के जो है स्टार को अगर इस तरह से हम लोग देखते रहें, सो यू डोंट फाइंड अ डिफरेंस मच. लेकिन हम लोग किस तरह से मेजर करते हैं कि एक ऑब्जर्वेशन करते हैं जून में तो दूसरी ऑब्जर्वेशन करते हैं दिसंबर में. सो यू गेट अ 6 month ऑफ टाइम ड्यूरेशन, और मे बी इस तरह से ये काफी लंबे टाइम बाद जो है उनकी ऑब्जर्वेशन होती है, वन फ्रॉम वन पॉइंट टू अनदर पॉइंट. जैसा कि आप देख सकते हैं कि अर्थ जो था यहाँ पे मौजूद था जुलाई के अंदर, और जनवरी के अंदर जो है दूसरी जगह पे है. जो स्टार्स की शिफ्टिंग हुई है उसकी वजह से हम लोग पैरालैक्स मेथड के थ्रू स्टार्स का डिस्टेंस, मतलब कितने दूर स्टार्स, उनको काउंट कर सकते हैं, उनको मेजर कर सकते हैं. Here, as the Earth orbits the Sun, our perspective change, and nearby stars appear to shift slightly relative to the background stars. Using trigonometry, as you know कि हमारी जो साइंस है उसमें जो मैथ्स और फिजिक्स की आपस में एक दूसरे के साथ दोस्ती है वो कभी नहीं टूटती, तो ट्रिग्नोमेट्री के थ्रू जो है we can calculate the distance of the nearby stars. And the method that we use to work for the star within few thousand years from the earth, ये जो है ज्यादा डिस्टेंस की ऑब्जेक्ट्स को मेजर नहीं कर सकते, ये सिर्फ नियर बाय स्टार्स जो है हम लोग उनको मेजर कर सकते हैं. जो बिलियंस एंड बिलियंस और दूसरी गैलेक्सीज में स्टार्स हैं, we cannot measure through this method. So let's talk about the solar system. What is in our solar system? The solar system is made up of matter which is gravitational bound to the sun. It includes much more than 8 planets. As you know, the solar system is composed of one star, which is our sun. Hamara sun jo hai, that is our star. And there are 8 planets and 5 plus dwarf planets and hundreds of natural satellites. Means jo hamara moon hai, which is a natural satellite, is tarah ki 100 plus natural satellites jo hai hamare solar system mein maujood hai. And there are billions and millions of small bodies that is known as asteroid, comets, or trans-Neptunian objects, countless small debris, meteorites in orbiting around the sun. So all these objects are here. Actually, if you are here, so maybe you can note down some questionnaire if they're asking, or Zainab, you can note down as well. Maybe I can make you co-host, so you will be able to see all the questionnaires. Zainab? Okay. The sun is at the center of our solar system, is our star. हम लोग कुछ वीडियोस भी देखेंगे जिसके थ्रू, एनिमेशन के थ्रू, it will make things easier for you to understand. There are 8 planets जिसको आप लोग देख सकते हैं here in this picture. The largest spherical object in orbit around is the sun and the 8 planets here. There are 2 types of planets, the small rocky planets, or maybe we call them inner planets, and there are some gaseous planet or gas planets. There are supergiant gas planets as well, just like Jupiter, as you can see here in this picture right now. And there is Saturn, and small terrestrial planets or rocky planets are Mercury, Earth, Venus, Mars. And we have some dwarf planets जिसमें हमारे Pluto, Iris, Makemake, Sirius, all these are dwarf planets. Small spherical object around the sun located either in the asteroid belt or Kuiper belt are called dwarf planets. We officially recognized 5 of them and call them dwarf planet, but 100 more could fit in this category. So natural satellites जो हमारी काफी सारी हैं, जो कि हमारे moons के काफी सारे, Jupiter के काफी सारे moons हैं. हमारा एक ही moon है जो कि हम लोग Earth के साथ connected है, natural satellite, that is our moon. But there are so many moons orbiting around the Jupiter and many other planets that we have in our solar system. Many are spherical and are too larger than planet Mercury. कुछ हमारे moons जो हैं वो Mercury से भी ज़्यादा बड़े हैं. So, as you can see here now in this picture, जैसा कि आप लोग इस पिक्चर में देख सकते हैं, there are so many planets mentioned over here, जिसमें टाइटेनिया, प्लूटो का शारन, there's so many of them. टाइटन के अलावा if I see Io, Europa, just like we are still discovering from other exoplanets. We will talk about exoplanets as well, जो कि it is going to be discussed in later on these slides. अब asteroids क्या होते हैं? Asteroids are actually rocky bodies when with irregular shapes which are smaller than dwarf planets are called asteroids. जो हमारे dwarf planets से छोटे साइज में rocky bodies मौजूद हैं स्पेस के अंदर, we call them asteroids. There appear to be million in our solar system, mostly located in asteroid belt. Asteroid belt में ज्यादातर हमें दिखते हैं ये सारे asteroids. I hope you all can hear me right now loud and clear. आप लोगों को यकीनन कोई मसला नहीं हो रहा होगा. Okay, so let me move to the next part. Here is the link as well in the slide. And then we have some comets. Comets are small icy objects. When they approach the sun, the ice turns into gas and reflects sunlight. It gives comet a tail. जिसकी वजह से हम लोग अक्सर इसको उर्दू में दुमदार सितारा भी कहते हैं, comet को. So you will find so many of them in our solar system. When main objects like as you can see here, when the main object of our solar system, wait, just give me 1 minute. Wait. So as you can see here right now, I hope it is clear to you. अब तक जो भी बातें बोली गई हैं आप लोग को समझ आ रही होंगी. अब तक तो हम लोग सोलर सिस्टम से आगे ही नहीं गए हैं. So Mercury, Venus, Earth, Mars, Jupiter, इससे आगे क्या है अब हम उसको भी डिस्कस करने वाले हैं. इन सारी चीजों के बीच में हमारे जो है बीच में एक एस्ट्रॉइड बेल्ट भी आती है, जो कि मार्स और जुपिटर के दरमियान एस्ट्रॉइड बेल्ट होती है. इसके अलावा काइपर बेल्ट जो है बियॉन्ड अवर नेपट्यून, रीजन बियॉन्ड नेपट्यून्स ऑर्बिट with numerous smaller objects. It can be visualized as second asteroid belt, but much wider than, composed of icy rockets, icy bodies. That's trans-Neptunian objects भी हम लोग इनको कहते हैं. Pluto is one of the largest known object located in this region. जो हमारा Pluto है, जो कि dwarf planet है, वो इस region में पाया जाता है. इसके अलावा the limit of our solar system is, as you can see here right now, it is approx what I say Kuiper belt. जहां तक हमारी ये खत्म हो रही है, इसको हम एक तरह से एक रीजन बोलते हैं. This is the whole region, what we call it, the limit of our solar system. But beyond this, what is there? There is a lot actually. As you can see here right now, there is our stellar neighborhood जिसमें काफी सारे हमारे stars आते हैं. Some of them are very very bright, and some of them are very famous as well, just like Sirius, जो कि हमारा सबसे brightest star है, Polaris, जो हमारा pole star कहलाता है. You can see so many stars over here with their names right now. Sirius is over here right now, and what else is there in our sky? और ये कुछ मिलके it makes up to about what I say 30 light year distance पे ये सारी चीजें मौजूद है. मतलब 30 साल पुरानी जो रोशनी है उस पे ये सारे स्टार्स जो हैं एग्जिस्ट करते हैं, जो अभी आप लोग देख रहे हैं. फिर when we talk about our what I say Milky Way Galaxy, it's actually an artistic expression. अभी तक Milky Way Galaxy को किसी ने टॉप व्यू से नहीं देखा है. This is actually an artistic expression. एक आर्टिस्ट की एक्सप्रेशन है जिसकी थ्रू मिल्की वे को हम लोगों ने शो किया है, which is about 100,000 light year distance. इसका जो डिस्टेंस है या इसकी जो पूरी गैलेक्सी के जो को मेजर किया जाए from one end to the other end, it's almost about thousands of 100,000 light year, मतलब 1 million light year almost. And then, as you can see here, there are billions and billions of stars, and in that stars there are some exoplanets. इन हमारे stars के अलावा कुछ हमारे दूसरे stars हैं जिसमें we found some planets as well. We call them exoplanets. इनको हम exoplanets कहते हैं. और अब तक कोई तकरीबन 45,000 exoplanets astronomers ने discover की हैं. This is another artistic expression of exoplanet, as you can see here right now in this picture. So what else is there? There are some nebulas in space. These are the gas clouds, and this is the cluster of stars. And here we can see another image of Milky Way Galaxy where, so here we are. This is just a small part. यहाँ पे जो एक डॉट के थ्रू शो किया गया है, ये हमारा यहाँ पे हमारा सन मौजूद है, मतलब इस जगह पे हमारा सोलर सिस्टम मौजूद है. और हम लोग को जो कि स्टार्स विजिबल थ्रू नेकेड आई जो हमें दिखते हैं, वो सिर्फ इसके फ्रंट रीजन के दिखते हैं, जो कि हमारे पूरे सोलर सिस्टम के अंदर या हम लोग की गैलेक्सी के अंदर से जो हम लोग व्यू कर सकते हैं, उनमें कुछ हमें स्पाइरल गैलेक्सीज भी दिखती हैं. और स्पाइरल गैलेक्सी के अलावा एज यू कैन सी, किसी ने अगर डार्क स्काई को देखा हो तो हमें डार्क स्काई में मिल्की वे गैलेक्सी का एक आर्म दिखता है, क्योंकि हम उसके आर्म पे मौजूद है, एज यू कैन सी हियर राइट नाउ. कैन यू इमेजिन कि व्हाई वी सी दिस बिग क्लाउड इन द डार्क स्काई? बिकॉज काइंड ऑफ एन आर्म, एक आर्म जैसी चीज दिख रही होती है हमें, बिकॉज वी आर प्रेजेंट ओवर हियर. वी आर नॉट एट द सेंटर ऑफ द गैलेक्सी. मिल्की वे गैलेक्सी के सेंटर में मौजूद नहीं है. एंड देन व्हाट इज बियॉन्ड? So we can also figure out or find out through optical telescope Andromeda Galaxy, which is in our neighboring stars, which is 2.5 million light year distance away. ये कोई what I say 2.5 light year distance, ये इतनी पुरानी रोशनी जो है, ये भी आज हम लोग इसको भी देख सकते हैं. There are so many participants who are raising their hands. I'm gonna include your questionnaires after finishing this part. ठीक है? And we have other galaxies. 28 million light year distance पे हमारी ये गैलेक्सी मौजूद है. इसके अलावा Whirlpool Galaxy, it's a small companion, 31 million light year distance पे मौजूद है. And then there is Barrett Spiral Galaxy, जो कि 69 million light year distance पे मौजूद है. इनके अलावा you can also see there is a collision happening in space. The galaxy is about 300 million light year distance पे जो मौजूद है, उसको भी हम लोग देख सकते हैं here in this picture right now. इन सारी चीजों के अलावा there are some astronomical tools that you can use to find out. आप सब लोग को, मुझे पता है, काफी सारे सवाल हैं. You all are raising your hands and I'm gonna ask you one by one the questionnaires. Aisha, are you there? Aisha, are you there? Okay, let me see. Yes, Aisha, are you there? Okay, I think she is. Can everyone hear me right now? Okay. Who would like to ask or talk something? Yes. Zara Batu. Sir, please again. Sir, please talk in Urdu. Can you please again? Okay, I can see. We are going to talk about all these artwork, everything later on. Just let me finish this and then we are going to accommodate you. Okay? So for now, I'm going to stop here for a while. और आप लोगों को मैं एक वीडियो शो करता हूं जिसमें you will get to see something very interesting. Maybe you have seen this earlier before. But I felt कि क्योंकि हमारे काफी सारे स्टूडेंट्स जो हैं, उनको ये वीडियो से काफी ज्यादा कुछ अंडरस्टैंडिंग होगी. थ्रू एनिमेशन they will get to understand about this solar system. Just give me 1 minute. So here we go. Just give me 1 minute. Okay.
I'm Paxi, and I come from a faraway planet. I came to Earth to meet you and tell you about my space adventures. Are you ready to explore your solar system? Oh, I love looking at stars. No wonder so many of you enjoy it. But wouldn't it be better to look at things from space? Come on, let's go. This is your planet Earth. Can you see half of it is bright, while half is dark? The Earth is spinning! The half of the Earth that is facing the sun is lit up, so you have daytime there, whilst the half facing away from the sun is dark, so you are in nighttime. It takes 24 hours for the Earth to make a full spin, a whole day. Look, there's the moon looping around, or, as we say, orbiting around the Earth. Did you know that the Earth orbits around the sun while it spins? The Earth and the moon always stay together. It takes 1 year for the Earth to make a full loop. Let's first go closer to the sun, but not too close. I don't want to burn my antennae again. Phew! The sun is our star. It is very hot, and it gives us light and warmth. Now, Earth is not alone. It is just one of 8 planets that orbit the sun. Let's have a look at them. The 4 small rocky planets closest to the sun are Mercury, Venus, Earth, and Mars. Mercury is very close to the sun, and it is the smallest planet of the solar system. Venus is very hot. It has a thick and dense air, poisonous to humans. I better keep my helmet tight, since this air is poisonous for me too. We've already seen Earth, your home planet. It is very special, you know. It is the only planet in the solar system covered with liquid water, rivers, lakes and oceans. And the only one to host life as we know it. Mars is covered in rusty dust, giving it a reddy-orange colour. That's why people call it the Red Planet. Maybe there was water here too, a long time ago. Look over there. After Mars, there are lots of smaller bits of rock. These are called asteroids, and there are millions of them. They form the asteroid belt, and they orbit the sun too. Further away from the sun, there are 4 truly huge planets, much, much bigger than the Earth. There are Jupiter and Saturn, the gas giants, and Uranus and Neptune, the icy giants. Here comes Jupiter, the biggest planet in your solar system. It is so nice with its colourful stripes of gas, isn't it? The great red spot you see is a swirling storm that could fit 2 Earths inside it. Do you know that many planets have their own moons, just like the Earth? Well, Jupiter has more than 60 of them. And look at Saturn, with its spectacular rings. They're made of billions of tiny pieces of ice, rocks and dust. Uranus and then Neptune are really cold and stormy, so I wouldn't like to go there on my holiday. Now, we have seen all of the planets in your solar system and some asteroids. What shall we do next? Are you curious to see more? Then let's travel even further away from the sun. Brr, it's really cold and dark out here. Hey, that's Pluto, a dwarf planet. Wow, what are those dark objects? They look like giant, dirty snowballs. Wait, one of them is coming towards us. Now I see. This is a comet. It is made from rock and ice. It resembles the asteroids we saw before. But let me tell you, it is very different. This one is heading in towards the sun. Next time, we'll follow on together to see what happens. So, that's the solar system. 1 star, the sun, 8 planets, over 100 moons, and millions of asteroids and comets. What an exciting place!
Okay, for now, it was a small video break sort of thing. आप लोगों ने वीडियो में देखा कि how this solar system actually look like. अभी हम लोग सोलर सिस्टम से आगे भी चले गए थे, लेकिन मैंने सोचा कि दोबारा से एक छोटा सा रिवीजन हो जाए बीच में, जिसमें आप लोग को कुछ बताया जाए कि सोलर सिस्टम से आगे भी बहुत बड़ी कायनात मौजूद है, जिसमें काफ़ी सारे हमारे स्टार्स हैं. As you can see here in this picture right now, this is a Hubble telescope image which was taken in 1996. ये इतनी पुरानी पिक्चर है, और इसमें आप लोगों को क्या दिख रहे हैं? Who is going to give the answer? Write down in the chat box. What do you think what it is? These are actually here in this picture right now. Can everyone see this? What it is? I can see someone is answering stars. Any other answer? One is saying galaxy. Okay. So another. Okay. Meteorites. Okay. Galaxies. Okay. Interesting. Many stars. Rocks. Okay. Interesting. Actually, these are galaxies. Thank you so much for answering this. But these are galaxies. जिसने भी galaxies answer दिया है, so virtual clap for them. Or galaxies is the correct answer. These are actually galaxies, as you can see here in this picture right now. And within this galaxy, इसमें से कोई हमारी मिल्की वे गैलेक्सी भी हो सकती है, और उसके अंदर सोलर सिस्टम के अंदर हम एक स्टार के अराउंड एक छोटे से प्लैनेट के अंदर अपने घर में बैठ के ये वर्कशॉप अटेंड कर रहे हैं. राइट? कैन यू इमेजिन दिस? सो हाउ लाइट इज सो ब्यूटिफुल इन दिस इमेज, एज यू कैन सी हियर. यहाँ पे आप लोग पहले तो ये देखिए कि कितनी बड़ी हमारी यूनिवर्स है, जिसमें इतने सारे हमारी गैलेक्सीज मौजूद हैं. अभी तक जो हम लोगों ने गैलेक्सीज हबल टेलीस्कोप से फिगर आउट की हैं, विच इज़ अ स्पेस बेस्ड टेलीस्कोप. इसके अलावा आई एम गोना मूव फॉरवर्ड टू द नेक्स्ट पार्ट. नेक्स्ट स्लाइड. आई होप इट इज़ गोइंग टू वर्क. इट्स लिटिल स्लो राइट नाउ. आयशा, वुड यू लाइक टू ऐड एनीथिंग? अभी यहाँ पे हमारे पास काफ़ी सारे सवालात हैं. येस, यू कैन अनम्यूट योरसेल्फ एंड ऐड ऑन समथिंग. How is all these? आपके लिए भी काफी interesting होगा, because she makes a lot of interesting art. Yes. So
I
these
think
are
it's always fun to learn more in depth, because I think this universe world will never end. जितना आप explore कर लो, there's always more and more. So I think this is good for all the students who are here, because this information is going to not only help you if you guys are interested as artists, if you guys are interested just as space enthusiasts, you guys should be really listening and absorbing this information, because it's going to really help you in your art projects, in your things that you are ideating for your exhibition or anything. So I think it's really informative.
yes. And I'm facing little technical challenges right now. My laptop is little hanged, which is going to be fixed within few minutes. Just give me 1 minute. So I forgot to delete one video within this presentation. It is taking a lot of time for me to load. So just give me 1 minute. I'm just gonna skip that video and move to the next part. क्योंकि वो वीडियो जो है I'll show you later on in a different slide. So maybe I should start from here. So let's talk about, this is actually a starry night, or what you can see when you go. अगर हमारी सिटी में लाइट पोल्यूशन मौजूद ना हो, तो you will get to see a lot of stars. And in this picture you can see a lot of different stars. But let's go deep in the sky. You will see moon over here. There is an application that you can download with the name of Stellarium. You can download it on your laptop, on your mobile phone. You can use it. It works with the GPS. It will detect all the celestial objects that are present in the sky right now. So, which is the moon is actually 1.2 light year distance away. मतलब जो हमारे पास रोशनी आ रही है, लाइट ईयर डिस्टेंस जो है उसका कोई 1.2 लाइट ईयर डिस्टेंस पे मौजूद है हमारा मून. मतलब ये भी रोशनी पुरानी है जो हमारे चांद से आ रही है. Even yes.
Rayan, I just want to add something. Some students are messaging me privately and they have a concern and they're asking me if they are supposed to make the notes of these things. And maybe you should just clarify them if they're supposed to, because I think they're confused in between the activity that is supposed to happen with the
Okay.
art thing. Can you just tell them, is this something that they should be doing?
Okay. It is just an information. If you are making notes, it's good. The recording is going to be there. You will receive an email of recording as well. You will get to see the recording later on. If you want to make notes on this, it is going to be very good for your learning. And then there is Venus. Let me continue with this topic. Venus is almost how much light year distance away? My mouse is actually, which is almost approximately 5 minutes और what I say light year distance away. हमारे जो और दूसरे stars हैं उनका भी कुछ light year distance, जो नियर बाय stars हैं, जो हमारे neighborhood में stars मौजूद हैं, उनका light year distance आप लोग को यहाँ पे दिख रहा होगा. कुछ 200 साल पुराने light year distance पे हैं objects मौजूद, कुछ thousands of light year distance पे मौजूद हैं. Andromeda Galaxy, as you can see, which is 2.5 million light year distance पे मौजूद है, that you can also see in the sky clearly through the telescope. अगर आपकी telescope काफ़ी अच्छी हो, you can see in the sky. And this is it for now, and I'm gonna add few more points यहाँ पे. I hope someone is here. So we have our NASA solar ambassador with us here in this room. Let me just invite him and introduce him sooner as possible. Let me add him and make him co-host, and let me just unmute yourself and yes. Okay. So we are going to begin with this, and the next slide is all about our special guest speaker. So Aisha, you can introduce. Are you there? Yes. Okay.
Good morning.
Good morning. It's very early morning in USA, so he is
Yes, it
joining.
is.
What time? What time is it right now? We have almost 50 participants over here, and the students' age group is almost 10 to 16, as we had discussion before. So,
Perfect.
Aisha, yes. So, Todd is actually NASA Solar Ambassador. He has been working as a NASA Solar System Ambassador for almost more than 12 years. He witnessed the night sky from many different longitude and latitude from all over our home, which is planet Earth. Todd also realized that we all are continuous explorer, whether looking up at the sky or looking down back to the earth. We are always exploring something. His style is energetic, motivational, and laced with humor. Todd's energy is such that he gives himself goosebumps during presentation. You will get to see the passion well up inside him becomes very evident. Todd invites everyone to join him on this awesome journey of space exploration, self-discovery as well. He feels that a successful presentation is laced with laughter, inspiration, and altered view of the universe. So here we have Pace of Discovery, a personal journey with our special guest, Mr. Todd. Yes.
Well, thank you. Thank you very much, and good to see everybody. I don't want to hijack your presentation. We're 15 minutes early, so if there's something you wanted to conclude with on your part, feel free. I do have a PowerPoint that I will share, so I leave that up to you, the organizer. Do you want to finish and continue, or just get into my piece of it?
Okay. I think we have 15 minutes. Maybe we can take some questionnaires right now. for a few minutes if anyone would like to talk something, because we still have 15 minutes. Any
Yes.
participants who would like to turn on their mic, camera, ask question, or write down in the chat box, they're free to join. Yes, there's so many things that you are learning today. It's like mind-boggling space. So many things beyond the solar system. And yes, anyone would like to say something? Okay, because we are receiving so many messages, but right now everyone is.
I think in the meantime we can listen to what Todd has to say. He can share his part. What do you think, Rayan? I think students
Sure.
are still thinking about the questions.
Yes, I think yes. We will collect some questionnaires because questions are super interesting. Can we go into another galaxy? So we will explore. Yes. So yes, you may continue. I think they can write it down later on, and you can continue with the presentation. Good to see you, sir.
All right. Well, questions are always good. Make sure we have time for questions on my end. So I am going to click share screen. Does that sound right?
Yes.
All right. And trying to get into the right mode here. There we go. Does everybody see the first screen?
Yes.
Okay, you should have kind of a planet and the moon and the name of the presentation. Is that what we're saying?
It's visible.
Okay, good. So hello, everybody. My name is Todd. I am from the United States. Let me just say I was born before Apollo landed on the moon. That's kind of my introduction. That's how old I am. I'm really, really, really old. I was born a few months before Apollo 11 landed on the moon. That's my claim to fame. And so what I wanted to do today was take a little bit of a departure from what I normally do. I can be very technical and, you know, lots of big words and stuff like that. And then I was approached to do this, and I really wanted to talk about a journey, right? Because James Webb Telescope has been on such a long journey. It's been over 30 years, and a lot's happened in 30 years. And what James Webb Telescope was originally supposed to do, that's all changed, right? And that's kind of what the world is about, right? Is change. And I really wanted to tell my parallel story of change. And so I've called this Pace of Discovery. And what I really hope everybody gets out of this is now is the time, if you're at all interested in space or astronomy or science, now is really the time to get into it. And I was talking with a friend of mine who's a space astrobiologist a couple of weeks ago, and we both agreed that we wish we were both back in college, right? Because the explosiveness, the learning and the knowledge and the information that's coming from space and astronomy around is just unbelievable. We're at a point in time in history where somebody can dedicate their entire life just on one little narrow aspect of stuff. When I was young, I mean, to study astronomy, you studied everything because that's what there was. It was just everything. Knowledge wasn't that great on specific topics. So really want to talk to you about my journey, and I'm going to parallel along with it with the James Webb Space Telescope. And towards the end, we'll get into some cool pictures and stuff like that to really understand what the telescope is going to do. But let's start on our journey. Any questions so far? Good. All right. All right. Everybody see this slide, a picture of me in the telescope? All right, good. Got heading out there. So the journey starts. And I had grown up always wanted to be an astronomer. I grew up in an area where there wasn't city lights. You could see the dark skies. And I fell in love very early with astronomy and just in stargazing, right? And like I said, I was born in the age of Apollo, and I grew up in the 70s. And then in the early 80s, this TV series came along, put on by Carl Sagan. It was called Cosmos. I was done. That was it. Astrophysics, that's for me. No hands on. And that was in the area of the mid 1980s. And then at the same time, there was this concept called the Next Generation Space Telescope, which ultimately became the James Webb Space Telescope. And at that time, it was supposed to replace Hubble, right? It's been called the Hubble's replacer. And then, things happen. And as I got into high school, and I'm all gung-ho, I'm going to go study at Cornell, I'm going to go do this, I'm going to go to the major schools, colleges. And as I got into advanced mathematics in school, I was like, oh, advanced math is really hard. It's really hard. And I love geometry and I love trigonometry, but starting to get into physics and calculus, I was like, oh, maybe this isn't for me. And so I had a long conversation with myself in 1985. And really the conversation lasted 2 or 3 days, in my head. And I was like, wow, if I'm not that great mathematician, which I thought I was going to be, what do I do with astrophysics? What do I do with astronomy? And I was like, if I'm really good, which I'm realizing that I wasn't in math, I was never going to work for NASA. I would probably end up being a college professor living off grants, living off money that people would give me to do research. And I really thought about it. And I was like, I'm not really sure that's what I want to do with the rest of my life, living off grants and college grants. And so I had that long conversation with myself and I says, what's bringing the world together? So if you remember the context at the time, Gorbachev was the Russian Soviet Union's leader. The Berlin Wall fell. And these are all things I never thought would happen in my lifetime. I never thought the Berlin Wall in Germany would fall in my lifetime. And here it is, it's falling. So I said, what's bringing the world together? And I said, commerce, business, international business. So I went off and I got decided to go to school in college to get an international business degree. Kind of squashing my dreams of astrophysics and astronomy. And we're going to get to how I've come full circle here in a few minutes. So simultaneously, the conversation started talking already about, hey, what do we do after Hubble? We got this big telescope, we're going to put it in orbit, and what do we do after that? We have to be thinking ahead, right? So this is what the scientific community is proposing. So during the 1980s, they're drawing up all the proposals and real conversations about developing the James Webb Space Telescope. And lo and behold, in the early 90s, it gets developed. So 1987 rolls around. My dreams of being an astrophysicist kind of like, hey. So I got to go off to college. I got new goals. I am going to save the world, international peace. We're going to bring the world together through commerce. And that was my goal. That was my mission. And I didn't save the world. I tried. But I was actually fairly successful in the world of logistics and international logistics. I love shipping cargo all around the world, seeing places, learning new ports, airports, maritime ports, etc. So very happy with that career. So let's talk about the telescope for a second. So 1989 was the first really official proposal In 1994, it was approved, and the telescope has gotten a reputation, justly, that it has been plagued by delays. And it has. Well, let's just be realistic. It has. There's no way to get around that. Much more money was spent than was originally initiated. And that just talks to the complexity of the telescope. So in 1997, they said, all right, we're going to do this in 10 years. A couple of years later, they go, all right, there's going to be a little bit of a delay. All right, don't worry, anybody. Don't panic. No panic. It's going to be delayed a year. Then another year. Then a couple more years, right? And so it keeps getting delayed. Now, there's all sorts of reasons for this delay. For example, I think it was 2007, the contract changed. The contract for building this telescope went to one company, and then that company was bought out by a hostile takeover by Northrop Grumman. So there is all sorts of politics and money and just scientific discovery and delays. So as we've learned again, last couple of days, the launching of the telescope has been delayed again. Now instead of the 22nd, we're looking at the 24th. At least we're not getting delayed in years. We're getting delayed in a couple of days. So I can live with that, right? We've already waited 30 years. So it just kind of shows the complexity of everything. Now, part of that complexity is scientific. It's got to pass a whole lot of tests. And here's an interesting point. The telescope, once it's launched and it begins to unfold in orbit, it has 344 single points of failure. So 344 operations it has to do in perfect sequence. If step number 24 doesn't work, telescope's done. Step number 137 doesn't work, telescope's done. Step 343, almost there, it doesn't work, telescope's done. Okay, so that goes to talk to the complexity. It's going to get shaken, it's going to get rattled on launch, it's going to be like in a blender, and all of these things have to work in perfect sequence for the telescope to work. So 344 single points of failure. There's no backup for each one of those points, not one backup. So that just talks to the complexity of this telescope. And then, of course, at some point during the development of the telescope, it goes from Next Generation Space Telescope, and it gets renamed James Webb Telescope after the NASA administrator. So I want to put into some perspective for your audience, and this is a great perspective. Everybody in your program today, pretty much everybody, has never lived without the internet. If you were born or lived prior to 1993, you have no idea what the internet is. It didn't exist. So the kind of official birthday for the internet is April 30th, 1993, the day we kind of officially recognize the World Wide Web. And it took over the world's communication and ability to learn, ability to communicate, the ability to do what we're doing right here now and today. So if you can imagine going from basically nothing in like 1992, 1993, and then just a few years later, over 50% is done by the turn of the century. And 7 years after that, basically the entire globe is sucked into the internet. So think about that. If we go back to this previous slide, when the telescope was even being developed or even thought of, the internet didn't exist. Nobody knew what the internet was. It didn't exist. And then by the time it got approved in 1994, there's this thing, oh, it's this thing called the internet, and people are going to be just being able to play video games, and the internet's never going to go further than that. Internet, it's a fad. It's not going to last. It's not going to change the world. So everybody just forget about the internet. Doesn't mean anything. So it just kind of goes to show that how long this program has been going on with the James Webb Telescope. So talking about the pace of discovery. So this is where my world starts to change, and this is where the entire world starts to change, right? And while the world sleeps, something happens. So in the 1990s, the pace of discovery of all branches of space and astronomy just explode exponentially. All fields was, we're finding out about dark matter, cosmic background radiation, asteroids, the sun, the planets. We're sending probes out to Mars and Venus and Mercury, and it is just exploding. So for the audience here today, now I wish I was back in college. I wish I was young enough to kind of live my life over again. Not that I have any regrets. Now is the greatest time to get into this, to get into astronomy. In the next 100 years is just going to be amazing. So I want to put that also in perspective. So in all of history, when you think about the history of mankind, documenting writing about astronomy, the ancient Chinese, the Arabs, Library of Alexandria, and ancient Egypt, all the ancient cultures to modern day, all the writings of famous authors, Europeans, Americans, all the countries investing and doing research, building telescopes, advances in rocketry during World War II, all the universities around the world writing textbooks in the 50s, 60s, and 70s, all writing text books on space and astronomy. That 50% of everything ever written about space and astronomy in all of humanity has occurred since 1995. Just think about that. That is how mind-blowing the pace of discovery is right now. It is mind-blowing. And the James Webb Telescope is going to change everything that we even know currently. We expect to be rewriting textbooks for the next 100 years based on what we find from the James Webb. And here's a fun fact for your audience. Almost 100% of modern day astronomers, space science, astrophysicists, they don't look through telescopes. Technology has changed that. Very, very few astronomers nowadays look visually through telescopes, like going up and looking, hey, oh, that's really cool. Oh, look at what I found. That's not astronomy modern day. You can still do it, absolutely. But if everything is algorithms, everything is mathematics, it's not even mathematics. If you have an interest in, say, botany, plants, if you have an interest in geology, dirt, rock, soil, there is a future in space. If you love growing vegetables, okay, they're growing chili peppers right now on the space station. Whatever it is that you love to do, working with animals, you love architecture, anything, it's getting to a point where very, very soon in the next few years, there's a role for that. They're already talking about 3D printing houses and building on Mars. You're going to need gardens, you're going to need food, you're going to need medicine, you're going to need all of these things. Astrobiology, astromedicine, astrogeology. So whatever you can think of, there's going to be a role for that in the future. So just think about that. Traditional view of space and astronomy, everybody thinks, oh, let's look through a telescope, see what we see. That was great, but it really wasn't getting to where we need to be. And so that's where kind of my story changes, right? And this is kind of where the pace of discovery, and this is where the James Webb Telescope story changes. So something else happened while the world was sleeping. It was called the Kepler Space Telescope. And if you right now, if you have a pen or a pencil or whatever, and you were to hold that pen or pencil, just think of the little top there. So Kepler stared at that little spot in space for 4 years, 24/7, 24 hours a day, 7 days a week, 365 days a year. And what people don't realize, Kepler was a different kind of experiment. There was a goal behind Kepler that really wasn't well known or published. And that goal was, how do we spend future money? In other words, what if Kepler didn't find a whole lot? What if it didn't find a whole lot? Looking for planets around other stars, right? Because that was the goal, find planets around other stars. If it didn't find many, that was going to drive the science in a direction. But if it found a lot, it's going to drive the next 30 or 40 years of science in a completely different direction. So Kepler's goal was not only to find planets around other stars, the goal was, if it finds a lot, we are going to fundamentally change the idea of where we're going to do our investigations in the future. It is going to change where we spend our future money. And that's really one of the bigger, quieter goals of Kepler, the telescope. So this is a simple graph. And basically you got the year along the bottom, and the number of detections going up. And you can see the top there in 2016. This is, graphs a few years old. I couldn't find anything more modern, but it gives you an idea of the pace of discovery. So I've got here in a red arrow kind of pointing down to, my time in college, the late 80s and early 90s. At that point, the universe was static. We weren't sure what else there was to learn. And in the terms of discovery, and one of the reasons why I decided not to become an astrophysicist, not just because I was not that great in math, which really disappointed me, the pace of discovery wasn't happening. The late 70s, early 80s, Voyager went past those gas giants, and we landed something on Mars, but it was actually kind of a really, really boring time, and really, really boring time. Nothing was really being discovered. And with the advent of technology, all of a sudden, you can see here in the graph, things are just increasing at an exponential rate. This is one of the reasons why I'm saying, if you're interested in space and astronomy, no matter the topic, you want to get into X-ray or gamma radiation, whatever it is you want to do, it's exploding in all facets. There's a lot of talk, about the TRAPPIST-1 system. We've discovered in one system 7 kind of Earth-like planets around one star. So, we talk about the solar system, our home, and the 4 inner rocky planets. Well, here you got the TRAPPIST, and they got 7, and that's just one star. And so a lot of focus has been on there. A little bit more detail in here. The TRAPPIST system, there are 4 planets within the habitable zone. And I'll talk a little bit more about later how James Webb will play a role in that. So the Kepler mission indirectly changed the James Webb Telescope mission. It changed because James Webb Telescope first and original goal was to find the origins of the universe, the origins of us. That was the goal. And now with the exploding discoveries all over the spectrum in our solar system, other solar systems, our galaxy, other galaxies, interstellar space, deep space, now we have a whole range of things to do. So the pace of discovery really started to change the James Webb Telescope mission, which we know has been plagued by delays. And so now you're the mission manager for the James Webb Telescope. You're like, oh my God, they discovered this, they discovered that. And I'm getting all these emails and I'm getting all these requests for, hey, let's change the focus. Let's do this, let's do that. And as a mission manager, I gotta be going crazy, right? I'm like, wait. I gotta build the telescope first. Slow down, I gotta build the telescope. Technology's changing, discoveries are changing. So the pace of discovery really changed the telescope's mission. And I wanted to throw this out there. This is actually something that I went on to Google just a couple of days ago. I did a talk a couple of years ago about 100 billion Earths. So based on what they found with the Kepler telescope, there was all these big announcements for a couple of years between 2013, 2016. They honestly believe, statistically, based on what they found with Kepler, that it could be very likely that there could be 100 billion habitable Earth-like planets in our own galaxy. And I'm not making this up. This is out there. It's in journals. You got to go back a few years. But yeah, it's out there. So this is really the exciting time, right? Who wants to discover the next Earth, right? I do. Oh yeah, I want to discover the next Earth. And then once you find one, you're going to find two, and you're going to find three, and then you're going to find six, and then you're going to find 10, and then you're going to 20, 30, 50, 60. And all of a sudden, everybody on Earth can have their own Earth. Yay! And unfortunately, we'll probably pollute it and destroy it and use up its resources, but that's a completely different story. So this is real, this is out there, and this is also telling my story about, yeah, I went off to college, I gave up my dream as an astrophysicist because I didn't think I was going to be very good at math. But this is where it starts bringing me back into it, right? And, you know, hey, I'm not an astrophysicist, so why am I volunteering for NASA, right? So, so I've been, it's almost been 14 years. And so I love to talk about it, right? So community engagement. And this is where some of you in the audience can think about. Maybe you're not great in math, and maybe you're not going to be a great botanist, and you know, maybe studying, you know, phytoplankton is not for you. But if you like talking about it and you like communicating it, there's a role for you. Public relations, communications, you know, be a communicator, be an educator. You don't need to be the scientist. Scientists need people who can communicate what they discover. So there's a role for everybody in this. And that's kind of where I come back into the fold is I was a great communicator. I understood the concepts and, you know, everything was happening. So I really just wanted to be a communicator. And that's kind of how it brings me into where I am today. So let's talk about asteroids, for example. And you see the writing in the middle, the red arrow down, that was me in college in the 1980s. It was really, really boring times in the 80s. Nobody was discovering anything. You know, like I said, everybody thought the solar system was static. We knew there was a bunch of asteroids in the belt, and you know, they occasionally floated around, and occasionally these snowballs called comets came around, but that was it. Again, technology changed all that, and you can just see this graphic where the discovery date come around 2000, mid-late 1990s, technology changed. All of a sudden, there's this thing called the internet and cell phones. I can remember a day when cell phones didn't exist. They had that long cord. You had to kind of speak with the phone, right? Yeah, I grew up. Nobody knew what a cell phone was. On American TV during the 70s, you had like the $6 million man who had this big clunky thing he was in the car. Yeah, hi, how you doing, right? And that was all fantasy. You know, Star Trek, you know, hey, Scotty, beam me up. that was all fantasy. That wasn't going to happen. That was smartphones. Smartphones will never happen, right? No way is this little teeny phone on my Apple wristwatch. There's no way I'm going to be able to communicate there and do a calculator and read time. And I'm never going to happen. So again, we come full circle. And 10, 15, 20 years from now, what is your life going to be like? You're gonna have technology where you're gonna be like, yeah, I grew up with smartphones. Ah, boy, you old. You grew up with smartphones. Oh boy. In the future, they could probably have transparent aluminum pads, right? I took that from Star Trek. Transparent aluminum, right? You never know what's going to happen. So I decided to throw this in here if you guys are interested. So there's a website that I followed for a long, long, long time. It's called spaceweather.com. And at the bottom of the page, they update it every day for near-Earth asteroids. So on December 13th, a couple of days ago, there was 2,243 potentially hazardous asteroids. And it gives you the asteroid name. It gives you the date it's going to fly by. It's going to give you the distance, the velocity, how big the object is. So yeah, every single day, we as a species potentially may not exist the next day. That's scary, but at the same time, it's rather comforting. It's comforting to me because we've been here millions of years and we're still around. And so, if you're at all interested in making a career just studying asteroids that fly by the Earth, there's a job for you. Space weather, there's a job for you. You want to get into space meteorology, coronal mass ejections, sun and solar flares that, we need satellite protection from these solar flares. If that's your interest, there's a job for you in the future. So the pace of discovery, title of this program, is really all about, it's exploding. And now time, if you're young, and even if you're still not in college, even better. The younger you are right now, because by the time you get to college, things are going to change again. So stay ahead of that curve. So this is on spaceweather.com, and it's at the bottom of the page. So go to this website, just keep scrolling, then you find it. So I kind of touched on this a little bit. So in 2004, I have a new beginning. And in fact, I was watching TV one day and I was watching politics, right? And it just dawned on me, right? I'm watching this political stuff on TV, which I wasn't terribly interested in. But what got me was all these people who saying they're an expert in something. And some of these people were not experts. And I got to think, I'm like, I'm not an expert, but I don't know a lot more than most people about a topic. So instead of calling myself an astronomy expert, I said, I'll become an astronomy educator. I'm not saying I know everything, but I can communicate. And that was kind of my change. That was my new beginning in this. And so it's never too late. Even when you get old, you can still, branch off. I still do international logistics, supply chain. That's still how I pay my bills and I put food on the table for the family. But I said, I can do more than just that. I can go back to my love. And so in 2004, I was listening to a group, and I'll say old men. They were old men. And they said, and this is when I was living somewhere else. I've moved around the country quite a bit. And they said, there's a lack of real good presenters in the area. And I heard that, a lack of good presenters in the area. So I went over and I'm like, hey, if I put something together, can I show it next month? They're like, yeah, that's great. And it was so successful that the astronomy club in the next region said, hey, can you do the same thing to our club? I said, yeah, sure. Hey, that's great. Love to help. And then it just kept going and going and going. And before I knew it, I was a volunteer manager at an observatory, and it just kind of snowballed. And in 2007, there was a call out for community volunteers, and I applied. I got accepted. So, I've been doing this since 2007. So in the James Webb Telescope, as we've talked about, they continued having delays, management changes. 2007 is when there was that hostile takeover with Northrop Grumman. And I wanted to introduce kind of one other concept here. And if you're familiar with it, I personally find that the concept is getting a little outdated because it talks about one specific type of technology, but fundamentally it's still true. So there's something called Moore's law, and it really talks about transistors, and transistors are now just becoming really outdated as a technology, but the concept I think still really holds true fundamentally. Every 2 years, technology doubles, and that's even become faster and faster. I've heard one thing where there's a new technology every 7 seconds somewhere in the world. When you think about, all of everybody working on stuff, all the first, not just first world nations, all nations that are working on developing stuff, the Americans, the Europeans, the Russians, Chinese, Japanese, and, your country, Pakistan, India, Australia, everybody's trying to do stuff, right? But in the context of the space telescope, so just imagine that you're the manager of a telescope, plagued with delays, politics, money, the pace of discovery. Now your mission's changing, right? Now you've got this other problem, which is a potentially huge problem. You're years into this, and technology is doubling every 2 years. You can't spend the rest of your life and the rest of the money on constantly keeping up with technology. At some point, you have to say, that's it. I have to stop here. Kind of stop. I can't keep upgrading, a new system, a new computer brain for this thing, because you need to reconfigure it every time. And the new computer may not, the equipment may not be able to keep up with the new computer. So at some point, you got to say that's enough. So kind of putting it into perspective, Moore's law, the 2 charts we've already seen. And I just really want to emphasize the doubling of technology, the consistent exponential growth of everything since I was in high school, really. And I just really want to make sure you guys knew that in the 1980s, 1990s, it was really boring times. Nothing was being discovered. Very little was being discovered. And again, that changed in the 1990s. And Moore's, I think the concept of Moore's law, not specific, but concept, is what's applicable here. And even today, technology continues to explode, and technology continues to redefine what we're looking at, what we're studying. And by the time most of this audience get to college, a lot of this is going to be redefined again. So now is absolutely the best time to get into this. I'm going to skip over that. So currently, where are we today? For myself, I'm personally, 14 years into this. I do talks. I've done something on the Yale University. I've opened an exhibition down in Corpus Christi, Texas. I've been on live morning TV down in Houston. I've managed 2 or 3 different observatories by now, you know, volunteer observatories, you know, nothing super fancy. I love founding new organizations. I've done 3, one in Texas, one here in Pennsylvania where I'm at. You know, space fests or star parties. I do a lot of public outreach, and this is just part of it. And for the James Webb Space Telescope, you know, right now it's you know, where's its current journey? It's sitting on top of an Adrian rocket down in South America. It's being poked. It's there. Let's put this wire on. Let's put it there. No, that's not working. All right, let's do this. All right, we're good. So a lot of it is hopefully by Christmas Day. You know, we're going to have James Webb in orbit. This is actually this is a mock-up of the James Webb Telescope, and this was on display in Houston several years ago. And you can see me down there in the little red circle, and that's how big this thing is. And if you to the right, you can see some other people standing in the background towards the bottom of the photo. That's the Northrop Grumman engineers, and they were there to answer and ask any questions. So this is a life-size mock-up. Apparently it takes 12 people 4 days to build this model. And apparently it takes like two big tractor trailer trucks and 12 people in 4 days to make the model. Let's go the undiscovered journey way forward. You know, my personal journey. You know, maybe I'll end up on Mars. Who knows? But you know, the way forward on my personal journey is the constant communication. I want to communicate. And as far as the James Webb Space Telescope, you know, that's you know, it's the undiscovered journey yet so far. And what that picture is this is the cosmic background radiation. So this is the best blueprint that we have of our known universe. And we expect that the James Webb Space Telescope is going to entirely destroy every notion and concept that we currently have about the universe. And that's why there's so much attention on it right now. There's so many hopes that what the James Webb's gonna tell us, and it's gonna look at this, and it's gonna be able to zoom in on lots of features and really drive the future forward. By the time, you know, most of your audience, when you're adults and you're going to be talking to your kids, just the whole notion of what the universe is could be entirely revolutionized. You know, kind of destroy what you know. So a couple of pictures coming up, and then we'll conclude. So this is Jupiter, and one of the early targets for the James Webb, not only Deep Universe, but they really want to use James Webb to see if they can figure out the red spot on Jupiter. And a lot of the current probes, including the one that's there now, Juno, they're just not able to figure out the red spot. So they're actually hoping the James Webb Telescope, that's infrared, can stare at the spot in infrared and through different wavelengths, figure out what making the red spot tick. So we're all used to seeing Jupiter in, you know, nice other colors, but if you're James Webb and you're looking at Jupiter, this is what it looks like. And then just a comparison. We're all used to seeing Jupiter, the middle photo, and that's the visible light. I mean, those are, you know, what we see through telescopes or through current cameras. To the left is infrared, and to the right, if you're looking at it in ultraviolet, that's what it looks like. So talking about exoplanets. So I had mentioned earlier TRAPPIST-1 system. So what are we looking for, right? So if we start, James Webb, in theory, should be able to just kind of block out the sun and look at the planet, okay? So that's the goal, right? James, block out the sun. In this case, it's my head. Look at the planet. So what is it going to look for? What is it going to find, right? So if it finds something that's entirely carbon dioxide, we got like a Venus. It's a runaway greenhouse effect, right? Can't live there. Yeah, maybe you can. I don't want to live there. You can find something that is a lot of oxygen and nitrogen. We're going to say, high potential, water world, potential. And then what if we find some of the nitrogen and oxygen, but a whole lot of carbon dioxide? It habitable. If you remember Star Wars, Tatooine, it's going to be a desert world. So this is kind of really what we're looking for, right? The right combination of chemical elements. Almost done. And I wanted to show you a couple of photos, visible in infrared. So we're all saying that the James Webb Telescope is Hubble's replacer. It's true, but it's also a false. It's misleading. The visible, you can see here on the left, but when the James Webb is going to look at it, it's going to see on the right. Look at how many more stars it's seeing. That's because in the infrared, you pass through all the dust. Infrared, you're looking for heat signature, right? You're looking for the heat. That's what infrared is, right? You're looking for the warmth. So while the visible photos are really cool, really inspiring, really artsy, it's true, that's what it looks like. But what James Webb's going to do is see through all that dust, right? Because that's one of the problems that we have in optical astronomy. And that's why a lot of people who study astronomy, they're studying gamma, they're studying radiation, they're studying microwave background, they're studying in infrared, radio astronomy. You don't look through a telescope when you're working in these functions. Radio astronomy is still big. Here's another couple of photos. You can see the difference. The top one, left to right. So it's seeing through all that gas and dust. And then on the bottom, again, you know, the two differences between the two, it's seeing through it. And I think this is kind of my last photo before we wrap up. Lagoon Nebula, beautiful, beautiful, beautiful. But it's full of dust, and it's making for a great picture. I'd love to wake up at night and be able to see this beautiful Lagoon Nebula, you know, out my window. But the reality is, it's full of stars, and it's full of you know, prototype solar systems. And so if we can see through the dust, we can see these new solar systems and new things. It's really going to greatly increase our capacity for learning how solar systems form, you know, and how maybe life begins. And then, of course, this was the original goal. It still is a goal, studying the deep universe. You know, Hubble can only see so far back with its limitations. And this is the dream with the James Webb Telescope, is to kind of look back and see if it can figure out the Big Bang expansion. It may tell us there was never a Big Bang. Who knows what it's going to tell us? And that's the great thing about, discovery, and this pace of discovery that we live in, through this journey, not only of mine, it's going to become your journey. And so the journey is going to restart, right? You're the new set of dreamers. You figure out your way forward. There's going to be another next generation space telescope. There's not one right now, but the United States is and Europe is not the only ones in the game anymore, right? So many other countries are getting involved in space, and now there's a number of countries that are developing this capacity, including yours. So you're the next set of dreamers. Anything is possible. Now is the time. God, I'm so jealous. God, I want to be young and go back to college again, right? And just do this all over because it's so exciting. It's unbelievable. And then who knows? One of you may develop the next generation's telescope. One of you may make the next big discovery. It's not unrealistic. The journey is going to continue to restart, and now is really your time to restart it. And I'm going to conclude on this. There's a song that I've discovered recently. It's an American country song, and it's been around a while, and I hadn't really heard about it. And there's a quote in the song, and it says, "Life is just a leap of faith. Spread your arms, hold your breath, and always trust your cape." And the song is about a young boy. He believed he could fly. He put on a potato sack around his head, and he believed he could fly. And so he runs, he jumps off the garage. Yes, he hits the ground. But the story is, he goes through his entire life believing he can fly. And even as an old man, he still believes he can fly. And he's old and gray. He says, I know I can fly. I know I can fly. And he puts on his cape. And even as an old man, he's still jumping off the garage roof, believing he can fly. But the moral of the story is, always trust your cape. Whatever your cape is. Life is a leap of faith. And my journey changed. I had given up on my love and belief in astronomy and physics, and it came back to me full circle. I found a purpose, and that's my cape. That's my purpose. And I'm going to leave you with this. That's kind of it for me. This is the mock-up of the Space Telescope, and this photo is actually from downtown Dublin. I don't know what year this photo was taken, but this is Dublin, Ireland, and I'm gonna kind of leave it there, and that's my take today. So I thank you very much for allowing me to share that.
Thank you so much for being here, and thank you for telling so many things about James Webb Telescope, about your journey, which was like, okay, it's a big things happening in space as well as in your life journey. Like, you're doing so many things, and it's exciting to know. And we have very few questions, but very interesting. So the question is there any life exist beyond our solar system? Are there any aliens? These are our interesting questions that we have for now. And can we go to another galaxy? So all these interesting...
if you want me to talk to that for a quick second, I will.
Okay, so all up to you, because these are very curious mind kids, and they are interested to know.
So talking about life elsewhere, the really exciting thing is, there's possibilities of life elsewhere, even in our solar system, right? The moons of Enceladus, Europa, and there's possible evidence, for even stuff on Mars. But I'll take a quote from a movie, which I really love, and I still think about all the time. So if you've ever seen the movie Contact, and the actress is Jodie Foster, and at the end of the movie, somebody asks, "Is there life out there?" And I loved her response. It would be really boring if it wasn't. It would be really boring if we were alone. They think there's 100 billion Earth-like planets out there. You do the math, you do the statistics. So I personally believe, got my cape. I believe I can fly.
Yes.
I have to believe there is. Have we discovered it? Not to my knowledge. Aliens, let me just do one little quick thing about aliens and put this in perspective, right? Our sun is a dwarf star. Okay, we're not a very big star. You do not have to go very far out into the galaxy before we blink out. And what I mean by that, if you take a match, right? Take a match. And if you're in a field, when it matches right there, you can see it. The match is over here, and it's not so clear. Eventually, you walk far enough away from that match, you can't see the light anymore, right? It's the same thing with the sun. We are a very small star. You do not have to go very far out into the galaxy before you can't see our light in the blackness. Maybe there is this huge population of alien species and they're just crisscrossing the galaxy. Maybe they just haven't stumbled upon us yet. It's entirely possible. So think about that. The star is so small, you do not have to go very far out into the galaxy before you can't see our sun. And you can only see it through other instruments. So just food for thought. Go ahead.
Thank you so much for your time. And we are just about to finish this part. And I'm going to play a video. And we have all these, like, all the similar questions. I'm going to explain them in our native language, Urdu, as well, because some of students are facing little challenge in understanding English. So later on, I'm going to explain it. So maybe I'm going to play one small video, which is zooming into the universe. Let's see what it is. And I'm going to stop your screen share. Is it
Yep,
okay?
absolutely.
Okay. Okay.
Nope.
And just after that, I'm going to invite Aisha, and she is going to talk about NFT and digital art. Okay. Here we go. I'm going to start from my, interestingly, mobile phone. So flight through the Orion Nebula in visible and infrared light. Okay, for now, I'm gonna invite Miss Aisha over here. Thank you so much, Sir Todd, for joining us. If you want to leave, you can also, you have some work to do. It's early morning over there in US. So all your choice. If you want to stay, you can stay with us and see what we are doing here.
Hey, yeah,
And
so no, I
yes,
just wanted to thank everybody. If anybody wants to contact me personally, I'm personally open with that. If somebody wants to funnel questions through you or your group, perfectly fine with that. Somebody I think asked me where I am, where I live. I currently live in Pennsylvania, Massachusetts. I'm about 1 hour outside New York City. So there's a time zone difference there. We're 10 hours apart. But no, I got a job to do. I'm actually at my workplace. And so I'm going to kindly take my leave. Really
okay.
enjoyed this. I appreciate the invite. I'm willing to do more in the
Thank
future.
you so much.
So I thank you very much. And, again, if anybody wants to contact me directly, I have no problem if you give people my information,
Sure.
my email. So thank you,
Yeah,
and really exciting with the James Webb Telescope, and a great program you got here. So thank you.
we're super excited. Thank you so much. Have a
Thank you
nice
so much
day. Bye
for.
bye.
Ciao.
Ciao, ciao. Okay, so Aisha is going to talk about her NFT art, and I'm going to start my presentation slide from here back again, and we are going to discuss about Aisha. So we have Miss Aisha with us. She is co-founder of Cosmic Tribe and also director and CEO of Oshi Brownie, which she is going to talk about what it is. And she's working on most modern form of art, which is digital art, as you saw in this video before. आप लोगों को जो video दिख रही थी, that was all about space art. जो इतनी खूबसूरत खूबसूरत images आप लोगों ने देखी अभी थोड़ी देर पहले इस video में, that was all space art actually. So she is working in one of the modern form of art, which is space art and NFT. What is NFT? I have never heard before. And Aisha is going to explain what is NFT and art using machine learning and AI, which is artificial intelligence and machine learning (ML) in her art practices. She has received numerous awards, which include Zahur ul Haq al Haq. I don't know.
Yeah.
It's Akhlaq. Sorry, Zahur ul Akhlaq award for the best drawing portfolio. And I can see a lot of awards over here. Even I cannot count them. And she is one of the 15th emerging talent artist from here. She has recently displayed her work at the 15th Emerging Talent Show at VM Art Gallery. She has been a part of various groups, shows across the country, like Goyle Gallery for the group show Space Bar at IBS for her work Dark Skies Gaze Back, as well as she has exhibit her painting work for United Nations with the name of People, We the People, We the Art. Annual exhibition by the Embassy of Switzerland in Islamabad. She has displayed 100 photos project at Artist Stop Being Poor Gallery at Berlin, Germany. So she is going to talk a lot about space and art, and also not only art but digital art, specifically in NFT. So over to you, Asha. What is NFT and what is digital art and what it is?
Well, first of all, thank you for having me again. Like, I had a small introduction, but thank you so much for the long introduction and kind of speaking about all of
Yes.
my previous awards and stuff. Even I had forgotten about all of those things. So yeah, but yeah, I'm really excited to be talking about young kids who want to be artists. I mean, I'm assuming everyone who is here is interested in arts, especially digital art, and this is the domain which will be focusing on today. So my practice is about fusion arts. I do digital art, like even my backdrop that you see is the work that I've done. So I like using techniques which can expand on the idea of universe, space, futuristic ideas, but also looking at the traditional elements. So how we can, represent our own identity, represent what the culture is, but then mix it up with techniques which are global at the moment, which have impact, and which is like kind of trendy if you talk about competitors in art industry, and people who are practicing art at its best, basically. So this is as far as I could go in terms of how exciting that this time is, because anyone who is interested in digital art, I think this is a good time to take this as a career, because previously people used to think that the art is only what you see in the galleries, or maybe canvas art and stuff. But the art and its definition has constantly been expanded with the NFTs and stuff. So yeah, let's just talk about NFTs. But Ryan, are we like stopping the presentation, because I don't see that
Okay.
the slide
Let
anymore?
me, okay, I guess it was stopped. Yes.
Yeah.
So, what is NFT? I
Okay.
never heard about
Let's
this
just
word.
let's
What
just
is
dive in.
NFT?
Okay, let's just dive in. NFT is like, if I it's an abbreviation for non-fungible tokens. Okay, if I be very precise, and this is just general term, right? So what happens is that everyone here is students, right? And so I'm assuming, and this is how it is, that students have a lot of ideas. And if I talk about ideas, then I also talk about that there is now a way to document your original ideas in the form of an evidence now. So if you're familiar with the blockchain technology, I mean, most of you must have heard the term, bitcoins, and how the digital currency is like taking over, right, the entire world. And now people are thinking about paying each other in the digital currency, not in specific currencies which different countries have. Like, this is the easiest way I can explain the idea of what how people do the monetary stuff around NFTs, right? So in a basic sense, since I want to just clear the basics out first, NFTs are just like tokens on the blockchain. So blockchain is a technology, and you can research it more. Like, these are very technical terms, but blockchain is a technology on which tells us that which artist has which original work done at what time, and what are the credentials, and was it an original piece of work, was it inspired. So all of these things gets its own place, and it gets confirmed by the fact that, okay, an artist has done an original NFT, and this is by this artist. How you get a signature by an artist, that, okay, you people used to take autographs based on the original work. So this is another form of autograph, and also a way to show the public that, okay, my portfolio exists as an NFT. But the interesting thing about this is that, okay, I've explained you what NFTs look like. NFTs are has taken shape of collectibles. I mean, I'm sure many people among you are familiar with gaming cards, and those collectibles, Pokemon cards, these kinds of games we have all played. So Pokemon cards and this stuff that you used to collect as a kid, now they are being collected as, as NFTs. So it's another just example of how NFTs are evolving as a technology. And it's a way to show other people in its transparent manner that, you own something, and then that thing cannot be owned by someone else. Sometimes that thing can have that collectible, that art, that music, which I'm terming in the umbrella of the NFTs, can be collected by more than one people. But then that is another conversation. Okay, so you don't need to go so much deep in it for now, because that is additions. But NFT is a topic new in Pakistan, but I think the young generation should know what NFTs is, because if they dive into it now, they can learn how to create those NFTs out of their digital art. They can learn how to use their own creativity and turn their ideas into NFT. They don't necessarily have to be artists. They can be musicians, they can be writers, they can be creative thinkers, they can be graphic designers, they can be coming from a lot of different backgrounds, and they can have different interests. But this is something which is very interesting about NFTs, that now even the music singers, music people are doing NFTs. So this is just like the background of what NFT is, how it can be used, and it can be used by anyone, especially children and students, because students should know what this is.
True. So
Can we move
NFT.
next? Yeah.
Yes.
Yeah.
I'm gonna ask you. We have this slide only, and I'm gonna ask you a few more questions.
Okay.
Because we still have a lot of things to do. There are students who are asking what we are going to do tomorrow, what we have to do day after tomorrow. उसको भी
Okay.
थोड़ा सा हम लोग explain करना है. So कल जो है, let me tell you right now, कल हम लोग जो आज जितनी भी हम लोग learning कर रहे हैं, it's about the workshop, because I know कि हम लोग जो स्कूल की किताबों में साइंस के बारे सोलर सिस्टम के बारे में पढ़ते हैं, उससे आगे कुछ नहीं जानते. ऐसा ही है. अगर किसी को सोलर सिस्टम के आगे किसी ने अपनी साइंस की किताबों में सोलर सिस्टम के आगे पढ़ा हो, तो कोई मुझे बताए कि उन्होंने यूनिवर्स, नेबुलास, स्टार्स, गैलेक्सी के बारे में भी अपनी साइंस की बुक्स में पढ़ा हो. तो इसीलिए आई वांटेड टू गिव यू अ कंप्लीट आइडिया, बिकॉज द मिशन ऑफ जेम्स वेब टेलीस्कोप टू फाइंड आउट द इनिशियल गैलेक्सीज और स्टार्स, द ओरिजिन ऑफ यूनिवर्स, हम कहाँ से आए, ये बिग बैंग कहाँ से हुआ, उसको फिगर आउट करने के लिए मिशन जो है तैयार किया गया है, जिसको कोई 25 साल लगे हैं. एज आवर सर टॉड वाज शोइंग कि व्हेन ही स्टार्टेड हिज करियर, सो देयर वाज अ चांस इन 1989, तब से जो है कुछ न्यूज़ आना स्टार्ट हुई, और फिर 90s के अंदर पहला जो है मिशन के लिए हम लोगों जो है अमाउंट तैयार हुई कि इतने $1 मिलियन जो हैं दिए जाएंगे. नाउ द कॉस्ट ऑफ दिस जेम्स वेब स्पेस टेलीस्कोप इज $10 billion, which is a big amount. They have invested in 25 years. 25 years में जाके जो है ये जेम्स वेब स्पेस टेलीस्कोप तैयार हुई है, जिसके पीछे काफ़ी डिले आए. उसको पहले लॉन्च होना था, नाउ इट्स delayed, and finally they are going to launch on 22nd December this year. And why we are learning about space art and digital art and NFT art, because the current technology that we have right now, it's all digital. As you can see, we are connected in this digital world, and as you can see, Aisha's background and my background, it's digitally created. Who is the creator? And what you were watching in that video, who was the creator? And you watching the slides, who is the creator? All is done through digital tools. So Aisha is one of the founding people who is working in NFT art, which is one of the modern form of art. And I'm going to ask one more question to you, Aisha. What is digital art? Let's explain. बनता कैसे ये, कौन-कौन से tools use होते हैं, कौन बना सकता है? Yes.
So I think to explain that, I should share my screen, show some examples maybe. Yeah.
Yes, please. Yes, it's better.
Can you guys see my screen?
Yes, it's yes.
Okay. So because I've been working in a lot of different techniques, even in the digital sense, right? Because digital art, when I talk about digital art, many people confuse it with comics, right? So this is one thing that I want to clarify, that comics and manga or animations or whatever the cartoons that you see, even anime, right? That is just one form of creating the digital art, right? Because nowadays most of the digital art, people first write the code for the art and then the actual art is being created. So this is the most technical form of art that exists. It is not being explored much, but this is the way how people create those softwares which we use to create art, right? So if I'm using Photoshop as a tool to create art, then there was an artist that designed Photoshop, and there was some code written for it, and then it was done. So the examples that you see on my screen, and these are all forms of different art that I have. So let me just point you out, just so you have an idea what kind of digital art is there. Like this, I pointed it out. This is like sketch form, it's an illustration. Then you see a logo art, right? Next to it, there is a map. It's a cartographic art, right? This is a photo manipulative art, the black and white image, right? This is space art, which was done by 3D modeling plus Photoshop manipulation plus fabrication techniques. I'll go over some of the techniques. If you guys are interested, I can, there can be another detailed thing about it, but since we are short on time, so I'll just go over the basics of it, right? And also
Yes.
because we are talking about James Webb Telescope and the way information is being produced, right? Because this is the topic that we're having, like how the resolution is produced, how artists have such a huge role in creating this imaginary world, but then that world gets justified by the science, and science helps art, art helps science, right? So
True.
in that domain, I'll just jump into one of my projects that it's an ongoing project, but I like mixing fantasy with stars. So this is like something that I'm exploring. Not many people are doing it, so it makes me like kind of able to do that, because I think it's interesting to be the first person to do that. So, and this is another example of the work that I do, that I take different images, I look at NASA's archives, I see Hubble's archives, and then I find interesting images, I kind of mimic them in Photoshop, and then I paint over them. And in this
Yes.
picture, the idea was to use the culture and then also use the setup of the different space scenes. In this case, a planet, some space backdrops, and then I create my own world through that, right? This is one form of art. This is another piece that I did. Uh, this is another one. Again, you see the theme of space there. This is one of the piece that is actually now displayed internationally, so that's why it's also my backdrop. So I was using the aerospace, but then also fictional reality plus costume designing, because I like mixing my costumes in my work. Another piece
Yes.
which is also about how in our we I was trying to imagine that if we were to go in the space, like us human beings, but plus Muslims plus Pakistanis, we can be the people in space 20 to 30 years from now. That's not far. I think it can happen. So I was imagining that. So just
Why so
that.
late? 20, 30 years.
maybe
Okay, we
maybe
should go
earlier. No,
early.
I
We
don't know,
should
I
go
can't
early.
comment on that.
Okay, we should be early and go early into
Yeah, for sure.
space.
I mean, I would love to go
I
early.
love this painting. I love this is art, digital art. I'm sorry, not painting. It's digital art. Yes.
Yeah. So like parts of it was painted actually. So, these small details of nebulas, it was painted over because it was not there. And some part was done 3D modeled, and then some part was done painting. Like, this part I created out of nothing. So this part was like on my own creation, my own version of a spaceship, which has a touch of truck art in it, right? So this was my idea of how truck art would look like in space. And you can see those elements there, right? And our culture, the kind of attire we have here in Pakistan, the kurtas and stuff. So you see our resemblance in sense of the traditional plus the space.
Yes.
Yeah, so this was one of my project. The other one is Dark Skies Gaze Back, which I did with Rayan, and he was the researcher. This is the project that we did, and we displayed it at IVS Gallery, and we were looking at the ideas of dark skies plus the effect of light in a very different way. So we were looking at women personas. I was constructing a lot of jewelry out of discarded stuff like metal in this case, and I was kind of rejoining it to make forms of masks, which becomes a rebellion towards आप ये लोग use करते हैं ना the Snapchat filters and stuff, so it recognizes your face, right? So if you're supposed to wear this stuff, which are like masks like forms, so your identity is not recognized. And this was the idea, that you rebel the light, you rebel the scrutiny, you rebel the security of the system of internet, which is kind of scrutinizing us. And these are just examples of different costume designs made out of the idea of what dark skies is. It's my understanding, how I interpret it. These were also used as part of performance that me and Rayan did for different events. And this is an ongoing project. It's an ongoing thing. If you guys are interested, you guys can go, and Rayan can share the links with you guys. You guys can totally check it out on my Instagram. It's all there. There were some paintings, which was also done on
Okay.
the theme. So we worked on mixed media for this project, just scrolling through. So these are the
Okay.
characters that we
Aisha,
construct.
we have interesting question. So do we have to do this kind of art? No. It's one of the
This is
advanced
very
form of
technical.
art. I highly request you to learn these kind of artwork because it requires a lot of techniques, practices, digital tools to use. Aisha, can you name some of them if they are
Yeah.
interested to explore them?
Yeah,
some
so
tools?
for starters, like if you guys are interested, you guys can look at the easiest 3D modeling softwares. I only know ZBrush. ZBrush is not simple. I learned ZBrush, I learned Photoshop, I learned Medibang. Medibang is for my illustrations, and Photoshop is for my fabrication work, and 3D modeling, I use ZBrush and I use Blender. But also, if you want to animate those 3D models that you're doing, and you will see some of my animations too on my portfolio. So those are done with, what do you name it? Yeah, so it's Redshift and it's Cinema 4D, right? And if you're into illustration, then I recommend Illustrator. And that is something that you guys do if you're interested in logo design, graphic design, anything similar. But I like working with hyper reality, images of portraits with different designs of fashion forms. So that is a very technical thing. You guys can totally do that, but for that you have to learn a lot of softwares, a lot of softwares. A lot of time goes into this. But yeah, so this is like the kind of work that I did for dark skies. Other than that, this is another project that I did. Do we have time, Ryan, to go over this? I'm not so sure.
Yes, maybe just show a little bit images. How does it look like? What it is? Because
Okay.
there is an ML and AI used. Because machine
Yeah.
learning is used, artificial intelligence is used in art, which is
Yeah.
super exciting for me to know. Like
Yeah.
machine learning is not
Okay.
just limited to your softwares, to programs, but also in art. Yes, Aisha,
Yeah.
go ahead, please.
So this is a project, and I was the only Pakistani artist on this project, along with 20 other artists selected from the entire world. So I was here from Karachi, and then I had people from London. They were coders, and they were people who worked in sound engineering. I was a visual artist on this project. There was a team of 3, but this entire fellowship was composed of 20 people. And the project that what we did was we were actually examining, since we are going into an era where, if we talk about the futuristic sense, then artificial intelligence is not leaving us anytime soon. Okay, so it's going to penetrate everything. It's going to go in the art, it's going to go in the way we have our apps installed, it's going to go inside how we write stuff. So we can't escape it, right? So the project's purpose was to examine different emotion mapping abilities, right? That how do we feel about this, if it's going to turn all robots, so where are we going, like virtually, like automated fashion, and all of those things. Then during the COVID time, there we were not able to access the real models for the fashion stuff that I was doing. So what we did was we created a fashion show out of robots. Okay, and so this is interesting because at first, everyone was like, how is this going to be? But then we were seeing this model by Plutchik, a scientist who studied the emotions for the first time. And this graph shows you that he divided the emotions into 8 categories, like joy, trust, fear, surprise, sadness, disgust, anger, anticipation. So we thought it would be interesting if we created a bot, each for the each for each sentiment, right? And we named the project Sentiment, which also translates as a sentient. So this double meaning was attached because we were talking about sentiments plus a being which is responsive in terms of emotions. And also we were thinking about, because robots are going to take over, and this is what we see in the films too. So this was the idea. And what we did was that we created different discarded objects and their meshes, their digital fabrics, like this. You can see this picture. And we were gathering data from different apps. So we were looking at Twitter, we were looking at Instagram, and we were just typing hashtags like joy, anger, and we were seeing what kind of images people are putting out. And again, it becomes a data which tells us something about how people respond to certain emotions, what they associate with. And after having like thousands and thousands of images, we translated them as a color combinations, and we were just looking at the graph and how it translates back to that information, right? So then I designed some of the things, some of the costumes, and I designed these bots, and the bots wore my costumes, and we translated this into a webcam app. So webcam app will be accessible soon. It's not working at the moment because of a code thing from their end. But if it was able, then I would have shown you that if you guys see yourself in the camera, like I'm talking to you right now, then that code tells you based on these costumes that I've designed, like this was fear, and this was anticipation, this was happy, this was anticipation, this one is sad. So it's supposed to tell you which bot you are, like are you like more sad today, are you more happy today, based on the data that we are feeding it. This tells us that it was done through machine learning, it was done through artificial intelligence. Using them, we combined it with digital arts, and this fusion of 2 to 3 different mediums, this interdisciplinary approach gave us a new way of telling our thing. So this was the project. Yeah.
I think they want to know something more about space as well, and this is super interesting and like it is
Yeah.
beyond. If you try to understand and grasp the knowledge about this kind of art, it's so intense and so deep that you need a lot of time to understand how this process actually works. So thank you so much, Aisha, for being here and joining us. If anyone have any question, please ask. And then I'm gonna move toward our last part, and which is all about art related to James Webb Telescope. First, I'm gonna only specifically talk about जेम्स वेब टेलीस्कोप इन उर्दू. मैं आपसे ज़्यादा से ज़्यादा उर्दू में बात करूँगा क्योंकि बहुत सारे लोगों का मैसेज ये आ रहा है कि दे कैन नॉट अंडरस्टैंड इंग्लिश मच. तो मेरी कोशिश ये होगी कि मैं ज़्यादा से ज़्यादा उर्दू में बात करूँ और आप लोगों को समझाऊँ व्हाट इज़ जेम्स वेब टेलीस्कोप. जेम्स वेब टेलीस्कोप है क्या? ठीक है. थैंक यू सो मच. अगर आपका किसी कोई सवाल है आयशा से तो प्लीज़ आस्क. Otherwise, we are thankful for Aisha to joining us, and she has another meeting to join. And I know it's very late for you. I'm so
that's
sorry for
totally
this,
fine.
and but thank you
No.
for your time. Okay. Okay. Anyone would like to ask anything? Yes, they can raise their hand and go for it. Otherwise, yes, or maybe they can write down in the chat box. Zubair, do you want to ask something? Okay, Zubair. Okay, anyone? Okay, Raza. Okay, yes. Okay. I think. Okay, you can
Miss,
continue. Yes. जी जी बताइए.
हमें कौन सी तस्वीरें बनानी होंगी?
Okay, we will talk about this. Okay, perfect. I got an idea. We will talk about हम लोगों ने तस्वीरें कौन सी बनानी होंगी. We will talk about it. Thank you so much, Aisha, for joining us. You have. Thank you so much. Stay
Thank you for
blessed.
having
Hope
me.
to see you soon.
Hope to see
Bye
you. Yeah.
bye.
Bye.
Inshallah.
Take
Okay.
care.
Bye
Take care,
bye.
everyone.
Allah Hafiz. Allah Hafiz. Oh,
Hafiz.
okay. Now we are going toward another part of our presentation. That is, let's see what it is. Let me go further next, and it's about James Webb Space Telescope. James Webb Space Telescope है क्या actually? ये किस तरह से दिखती है और क्या होता है? James Webb Telescope किस मेथड पे काम करती है? क्या करेगी? इसका मिशन क्या है? ये जो है इंफ्रारेड आई ऑन द यूनिवर्स, हम लोग जो अपनी आंखों से चीजें देख रहे हैं ये विजिबल रेंज में चीजें देख रही होती हैं, राइट? आप लोग को यकीनन इस चीज़ का थोड़ा सा बेसिक आइडिया होगा कि देयर इज अ विजिबल लाइट जिसके थ्रू हमें चीज़ें दिखती हैं. कुछ ऐसी अनजान चीज़ें हैं जो कि हम लोग को अपनी नेकेड आई से नहीं दिखती. इस पूरे कंटेंट में आप लोग जो बातें सुनेंगे और समझेंगे, दैट इज ऑल अबाउट जेम्स वेब स्पेस टेलीस्कोप. और आर्टवर्क कैसा बनाना है, यू विल गेट टू लर्न अबाउट इट. हाउ वेब केम टू बी, इसके बारे में सर टोड ने भी बहुत सारी बातें बताई कि कब से स्टार्ट हुआ मिशन, कहाँ से स्टार्ट हुआ, एंड वाई वी स्टडी इंफ्रारेड लाइट. हम इंफ्रारेड लाइट को क्यों यूज करते हैं. लेट्स एक्सप्लोर द यूनिवर्स विद वेब एंड ऑल अबाउट द टेलीस्कोप. So how Webb came to be is actually when we started exploring the universe or our galaxies. Later on we decided कि अब जो है हम कुछ ऐसी चीज़ बनाते हैं जिससे हमें ओरिजिन ऑफ द यूनिवर्स पता चल सके. हमें बिग बैंग के बारे में तो पता चल गया था कि बिग बैंग कितने लाखों साल पहले हुआ, और उससे पहले की चीज़ों को भी डिटेक्ट करने में, उसकी ओरिजिन को मालूम करने के लिए कि वाकई में ये 13.4 बिलियन ईयर्स अगो या जो भी हमारी गैलेक्सीज हैं उससे पुरानी जेम्स वेब टेलीस्कोप जो है 400 बिलियन लाइट ईयर डिस्टेंस गैलेक्सीज को भी डिटेक्ट करने में मदद देगी. सो इट्स वन ऑफ द पावरफुल टेलीस्कोप जिसको बनने में कोई 25 ईयर्स लगे हैं. इसके अलावा व्हेन वी टॉक अबाउट टेलीस्कोप की पूरी अगर देखा जाए कि कौन कौन सी टेलीस्कोप हैं जब तक लॉन्च हुई हैं स्पेशली फॉर ऑल दीज पर्पसेस, जिसमें हमारी सबसे पहले आती है हबल टेलीस्कोप जो कि 1990 में लॉन्च हुई थी। और ये जो है इंफ्रारेड रेडिएशन में, इंफ्रारेड लाइट में भी और विजिबल लाइट में, अल्ट्रावायलेट लाइट में ऑब्जर्वेशन करती है यूनिवर्स की, और ये 1990 से लेके अब तक मौजूद है। देन देयर इज अनदर वन विद द नेम ऑफ चंद्रा जो 1999 में लॉन्च हुई और जो कि एक्सरेज, जो हम लोग एक्सरे मशीन्स यूज करते हैं, इसमें यूनिवर्स को ऑब्जर्व करती है। यू गेट इट? जो एक हमारे पास टेलीस्कोप होती है उसके उसके ऊपर एक लेंस लगा होता है, लेकिन इनके अंदर वो इंस्ट्रूमेंट लगे होते हैं जो एक्सरेज में यूनिवर्स को देख रहे होते हैं। और फिर देयर इज अनदर वन विद द नेम ऑफ इट्सपिट्जर। ये जो है 2003 से लेके 2022, मतलब अब जो है इसका फाइनली इट इज अबाउट टू एंड और समथिंग लाइक दिस, जो कि इंफ्रारेड रेडिएशन में हमारी यूनिवर्स को ऑब्जर्व करती है। नाउ लेट्स टॉक अबाउट एक्सपेंडिंग ऑफ आवर यूनिवर्स। आवर यूनिवर्स, जो हमारी यूनिवर्स है, आफ्टर बिग बैंग इट स्टार्ट एक्सपेंडिंग। हमारी यूनिवर्स जो है वो एक्सपेंड हो रही है। एज यू कैन सी हियर इन दिस पिक्चर राइट नाउ, सम ऑफ द इमेजेस आर टेकन इन द फॉर्म ऑफ इंफ्रारेड रेडिएशन, इंफ्रारेड लाइट। क्रैब नेबुला इसमें देख सकते हैं। किसी ने मुझसे ये सवाल पूछा था, व्हाट इज नेबुला और व्हाट इज, वेयर इज द डस्ट, डस्ट कहाँ पे है? सो ऑल दीज इमेजेस दैट यू सी कंसिस्ट ऑफ अ लॉट ऑफ गैस एंड डस्ट मेड अप ऑफ, और जो हमारे स्टार्स भी बनते हैं वो आपस में कोलाइड करते करते, जो हमारी हाइड्रोजन और हीलियम का रिएक्शन होता है, डस्ट पार्टिकल आपस में मिलते मिलते पहले तो एक सुपरनोवा एक्सप्लोजन होता है, और उसके बाद इट्स अ लॉन्ग लाइफ स्टोरी जो कि स्टार्स किस तरह से फॉर्म होते हैं। वी विल डिस्कस अ लिटिल बिट अबाउट इट एज वेल कि ये किस तरह से फॉर्म होते हैं। इन दिस पिक्चर यू कैन सी some ring nebula, some galaxies, a crab nebula, and many other images. Here, as you can see, ये वाली पिक्चर जो आप लोगों को मैंने पहले भी दिखाई थी, जिसमें स्टार्टिंग द डीपर इनटू स्पेस, ये पिक्चर में आप लोग को काफ़ी सारी गैलेक्सीज दिख रही हैं। इट कंसिस्ट ऑफ मिलियंस ऑफ गैलेक्सीज, और इन गैलेक्सीज के अंदर काफ़ी सारे स्टार्स मौजूद हैं, और इनके ऊपर लाइफ एग्जिस्ट करने के चांसेस ज़्यादा हो सकते हैं, क्योंकि अभी तक हम लोगों ने कोई भी एलियन लाइफ डिस्कवर नहीं की है। फॉर नाउ, इफ यू मूव टू द नेक्स्ट पार्ट, हाउ डज जेम्स वेब telescope started working, or how does it work? Capturing the faint or infrared light, ये जो है हमारे इमेजेस को, जो अभी तक हम लोग इमेजेस हबल टेलीस्कोप से लेते हुए आए हैं, वो इतने क्लियर इमेजेस नहीं है, क्योंकि वो इंफ्रारेड रेडिएशन में, लो इंफ्रारेड रेडिएशन में काम कर रही है। वी विल सी दिस एज वेल कि ये किस तरह से काम कर रही होती है। और जो हमारी जेम्स वेब टेलीस्कोप होगी, वो उसकी मेन पर्पस ही वो इंफ्रारेड रेडिएशन में। अब इंफ्रारेड रेडिएशन होती क्या है, इंफ्रारेड लाइट क्या होती है? एज आई मेंशन दिस अर्लियर बिफोर कि हमारी यूनिवर्स जो है वो एक्सपेंड कर रही है, मतलब फैल रही है। तो लाइट भी जो है वो स्ट्रेच हो रही है। जितनी लाइट स्ट्रेच हो रही है, एज इन दिस पिक्चर यू कैन सी कि लाइट के स्ट्रेच होने की वजह से जो हमारी विजिबल लाइट है, जो हम लोग देख सकते हैं अपनी सराउंडिंग में चीज़ें, वो विजिबल रेंज में आती है। उससे अबव जो है वो अल्ट्रावायलेट और एक्सरेज में आ जाते हैं चीज़ें, और उससे बिलो रेंज में जो चीज़ें आती हैं, क्योंकि एक्सपेंड हो रही है तो वो स्ट्रेच हो रही है, इसलिए इंफ्रारेड रेडिएशन के अंदर हमारे यूनिवर्स की जो पुरानी चीज़ें जो गुजर चुकी हैं, वो हमें इंफ्रारेड और रेडियो वेव्स में हमें दिखती हैं। इसमें ही हमारी हबल टेलीस्कोप भी काम कर रही है, और जेम्स वेब टेलीस्कोप का भी इसी में ही ऑब्जर्वेशन की जाती है यूनिवर्स की। अर्ली टेलीस्कोप डिजाइन ऑफ आवर जेम्स वेब स्पेस टेलीस्कोप लुक लाइक दिस। ये इनिशियली जो एक आइडिया प्रपोज किया था, उसका डिज़ाइन कुछ मॉडल यूँ था, लेकिन ग्रेजुअली स्लोली जो है इट टर्न इनटू अ ब्यूटीफुल जाइंट, जो कि इतना बड़ा आप हबल टेलीस्कोप जेम्स वेब टेलीस्कोप देख सकते हैं। इट्स अ 3-floor बिल्डिंग अप्रॉक्स। इसकी बिल्डिंग जो इतनी बड़ी बिल्डिंग है, इट इज़ मेड अप ऑफ so many material, and it is working on infrared light. So why do we study infrared light? Here you see some images. यहाँ पे आप कुछ images देख सकते हैं, जिसमें meerkats और fresh crocodile देख रहे हैं। ये आपको अभी सामने जैसा दिखते हैं वैसे ही आप लोग इसमें देख सकते हैं इस पिक्चर में। लेकिन जब इनको इंफ्रारेड रेडिएशन में देखा जाए तो आप इनकी हीट कि ये कितने, क्योंकि कुछ कोल्ड ब्लडेड एनिमल हैं, कुछ वार्म ब्लडेड एनिमल्स हैं, राइट। सो वार्म ब्लडेड एनिमल होने की वजह से मीट कैट जो हैं बहुत ज़्यादा ब्राइट दिख रही हैं। इसी तरह से हमारे जो स्टार्स होते हैं वो भी इंफ्रारेड रेडिएशन में अगर वो हॉट स्टार्स हों तो वो ब्राइट दिखते हैं। अगर कोल्ड प्लैनेट्स की बात की जाए, जैसा कि हमारे प्लूटो जो है कोल्ड प्लैनेट में आता है, इसी तरह से जो हमारा क्रोकोडाइल है मे बी इंफ्रारेड रेडिएशन में या इंफ्रारेड लाइट में, हमें प्लूटो भी कुछ इसी तरह से दिखता होगा। सो इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम क्या होता है? इसमें काफ़ी सारी जो टेलीस्कोप हमारी जो अब तक लॉन्च हुई हैं, जिसमें हबल टेलीस्कोप जो कि लो इंफ्रारेड लाइट में काम कर रही होती है, एंड देन देर इज हाई इंफ्रारेड जिसमें, और मिड इंफ्रारेड रेंज जिसमें हमारी हबल टेलीस्कोप काम कर रही है, करेगी इन फ्यूचर। आफ्टर 22nd of December it is going to launch and it will take a lot of time to unfold. It will actually unfold and work in space to explore the origin of the universe. So there are some three images जो कि आप लोगों ने पहले भी देखा कि मिड इंफ्रारेड लाइट में कैसे इमेजेस दिखेंगे, अगर नियर इंफ्रारेड इमेजेस हो तो वो कैसे कितने ब्राइट दिखेंगे और कितने क्लियर दिखेंगे, और विजिबल लाइट में जो हमारी विजिबल लाइट हमारी नेकेड आई से जो चीज़ें दिखती हैं वो कैसे दिखेंगे। सो दिस इज ऑल्सो नेबुला जो कि इसको समटाइम वी कॉल इट पिलर nebula, or because it looks like a pillar, so इसको हम pillar भी कहते हैं, pillar nebula. Then we have let's explore the universe with Webb. How do we explore it? So here is the beginning of ionization कि ये कैसे universe जो है start हुई और stars कैसे बनना शुरू हुए. So when we talk about the start beginning forming heat gas, आपस में जो न्यूक्लियर हीलियम और हाइड्रोजन का रिएक्शन होता है, उसके बाद दे स्टार्ट फॉर्मिंग बिगर गैस जाइंट, और बिग बैंग के बाद जो है स्टार्ट असेंबल इनटू गैलेक्सीज, स्लोली ग्रेजुअली गैलेक्सीज बिकम मोर मैसिव, और ये मैसिव गैलेक्सीज हमारी यूनिवर्स के अंदर, क्लियर यूनिवर्स के अंदर एक आपको इस तरह से दिखेंगी, जैसा कि आप इस इमेज में देख सकते हैं जो कि हबल टेलीस्कोप से लिए गए थे। इट टेक्स नॉट ओनली thousands years but billions of years to form, start from the beginning and turn into universe and thousands and billions of galaxies. So when we talk about the James Webb Space Telescope, it will be in our orbit of 1 million miles away. 1 million miles away की distance पे ये जो orbit करेगी, जो हमारे अर्थ ऑर्बिट से 1 million miles away ये ऑर्बिट कर रही होगी हमारी जेम्स वेब टेलीस्कोप। I'll show you one video as well. In that video you will get to see कि कौन सा ऑर्बिट में कौन सी टेलीस्कोप ऑर्बिट कर रही है। फॉर एग्जांपल हबल टेलीस्कोप का ऑर्बिट इतना ज़्यादा दूर नहीं है, बट आवर जेम्स वेब स्पेस टेलीस्कोप ऑर्बिट is actually 1 million miles away. So how do we detect them? Discover some of the first galaxies. हम इन इमेजेस को इंफ्रारेड रेडिएशन में देखेंगे, और इन इंफ्रारेड रेडिएशन को डिटेक्ट करने के बाद क्या करते हैं, स्पेक्ट्रोस्कोपी के थ्रू एस्ट्रोनॉमर्स फिगर आउट करते हैं कि ये इस गैलेक्सी के अंदर, सॉरी इस स्टार के अंदर कौन कौन से एलिमेंट्स मौजूद हैं, राइट। इसमें काफ़ी सारा केमिस्ट्री का भी काम है, इसमें काफ़ी सारी फिजिक्स इन्वॉल्व है, और काफ़ी सारी बायोलॉजी भी इन्वॉल्व है। वो इस तरह से कि हम आहिस्ता आहिस्ता कुछ बायो ऑर्गेनिजम्स और माइक्रो ऑर्गेनिज्म की डिटेक्शन थ्रू लाइट करते हैं। एस्ट्रोनॉमर्स जो डिटेक्ट कर रहे होते हैं, अक्सर सुना होगा कि कैसे पता चले कि कहाँ पे कौन से स्टार्स में हम लोग क्या देखते हैं स्काई में। वी सी ओनली लाइट शाइन इन द स्काई, जो हमें लाइट दिखती है उसी से हम लोग लाइट को स्टडी करते हैं टू स्टडी द यूनिवर्स। लाइट इज सो डीप एंड इंटरेस्टिंग टॉपिक टू टॉक अबाउट। सो लेट्स हैव अ फ्लिप बुक ऑफ गैलेक्सीज ओवर टाइम। फ्लिप बुक क्या है? अभी जो हमारी करंट गैलेक्सी दिखती है वो कुछ फर्स्ट इमेज है। अगर हम इसको स्टार्ट से देखें, सो बिगनिंग ऑफ के जो दो फॉर एग्जांपल एटम के अंदर न्यूक्लियर और फिजन फ्यूजन रिएक्शन होना स्टार्ट हुआ, और स्लोली ग्रेजुअली जो है वो दूसरे स्टार्स में चेंज हुए, वो फिर गैलेक्सीज बनी, फिर पूरी एक मिल्की वे गैलेक्सीज बनी, और ला 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 ला। यू गेट इट? It takes a lot of time, it takes billions and billions of years to complete this whole flip book it looks like very easy to understand अगर हम इस flip book को एक साथ इमेजेस में देख रहे हो तो अंडरस्टैंडिंग हमारे लिए काफ़ी ज़्यादा आसान हो जाती है. डायसेक्टिंग द ब्लैक होल. अभी तक हम लोगों ने ब्लैक होल को डिस्कवर और एक्सप्लोर ही कर रहे हैं कि ये ऐसी जगह है जहाँ पे अभी तक इसको कोई नहीं गया और कोई नहीं जा सकता. तो इंफ्रारेड रेडिएशन के अंदर जो हमारी जेम्स वेब स्पेस टेलीस्कोप है वो भी इसकी जो इसको डायसेक्ट करने में या इसको स्टडी करने में मदद देगी. इन सारी चीज़ों के अलावा वी विल ऑल्सो री एग्जामाइन आवर स्टार्स फॉर्म लाइफ एंड डेथ ऑफ अ स्टार, कि ये स्टार्स जो हैं कैसे बनते हैं और कैसे जो हैं how they form and how they die. So there is another nebula as you see in this picture. There is one visible light. जो visible light से हम लोगों ने टेलीस्कोप से इमेज ली है वो कुछ इस तरह की है, लेकिन इंफ्रारेड में you can see there you will get an idea कि इसमें और भी ज़्यादा डेप्थ आ गई है. जो हमारी फर्स्ट इमेज है, जो विजिबल लाइट में इमेज दिख रही है, वो थोड़ी सी इतनी क्लियर नहीं है, लेकिन अगर हम लोग इंफ्रारेड में देखें तो उसमें हमें और भी ज़्यादा डेप्थ में चीज़ें दिखती हैं कि बहुत सारे स्टार्स हैं, वरना हमें तो सिर्फ क्लाउड ही दिख रहा है फर्स्ट इमेज में. Can you see this right now? You will see only clouds over here. So, detecting molecules and star forming region, ये सारे stars जो हैं आप लोग इस टेलीस्कोप के थ्रू डिटेक्ट करेंगे. इन सारी चीज़ों के अलावा you will also examine our solar system. हमारे सोलर सिस्टम में जो जुपिटर है उसको फर्दर इंफ्रारेड रेडिएशन में अगर देखा जाए तो वो कुछ इस तरह का दिखता है. और इसके अलावा infrared light help us to find distant planet as well. As you can see, we will figure out other distant planet through our James Webb Telescope. That is going to be our future mission. स्पेक्ट्रोस्कोपी कैसे काम करती है? इट इज़ ओवर हेयर कि हम स्पेक्ट्रल रेंज के थ्रू जो है एक हमें ग्राफ मिलता है जिसके थ्रू हम लोग मालूम करते हैं कि ये ग्राफ जो है किस तरह से कहाँ पे जो है फ्लक्चुएशन की वजह से जो हमारे ओजोन है या हमारी कार्बन डाइऑक्साइड है इस पूरे स्पेक्ट्रल रेंज को स्टडी करके बताती है कि कितनी ज़्यादा हमारे इस प्लैनेट के अंदर कार्बन डाइऑक्साइड या ऑक्सीजन या ओजोन लेयर या मीथेन मौजूद है. It is just an example. The James Webb Telescope is not going to study about the Earth, but it is going to about the universe, stars, other planets, and also black hole. That was all about the James Webb Space Telescope. इसके अंदर जो हमारे फीचर्स हैं वो काफ़ी ज़्यादा डीप हैं. The basic feature, as you can see here in this picture, आपको कुछ honeycomb style structure दिखेगा जो कि ये सारे what I say मिरर्स हैं जो कि बेरिलियम जो हमारा मटेरियल है उससे मिलके बने हैं एंड दे आर कोटेड विद गोल्ड, दे आर गोल्ड कोटेड. और इसका साइज जो है कोई 21 फीट से भी ज़्यादा बड़ा है कोई. और जबकि हबल टेलीस्कोप का जो हाइट है, देयर इज़ अ पर्सन स्टैंडिंग नेक्स्ट टू इट, इसका जो हाइट है और जो इसकी डायमेंशंस हैं वो कोई 7 फीट तक है. लेकिन इसकी जो अगर मैं हबल टेलीस्कोप की बात करूँ तो कुछ बहुत ही दिस इज़ वेरी ह्यूज. सो स्प्लिटिंग लाइट इनटू वेब, यू विल सी कि लाइट को अगर हम लोग स्प्लिट करके देखें, अगर हम लोग स्पेक्ट्रोस्कोपी को स्टडी करें, यू विल गेट एन आइडिया कि स्पेक्ट्रम के थ्रू हम लोग काफ़ी सारी चीज़ों को डिटेक्ट कर सकते हैं, प्लैनेट्स को डिस्कवर कर सकते हैं और प्लैनेट्स में मौजूद एटमॉस्फेयर की कौन सी गैसेस एलिमेंट्स मौजूद हैं उससे इन स्पेक्ट्रोस्कोपी के थ्रू डिटेक्ट किया जाता है. सो हबल टेलीस्कोप इज ऑर्बिटिंग not so far, but James Webb Space Telescope is going to orbit at L2, which is Lagrange 2 point, जो हमारा 1 million miles away है, वहाँ पे ये orbit करेगा, which is far far away from the Earth. इसका प्राइमरी मिरर और सेकेंडरी मिरर कुछ इस तरह का है, जैसा कि टेलीस्कोप्स में मिरर्स होते हैं इसी तरह से इसमें भी मिरर है. द प्राइमरी मिरर इज दिस गोल्ड प्लेटेड बेरिलियम मटीरियल. इट्स ह्यूज इन साइज and there are multiple shields which is below this. There are 5 layer of shield, multiple sun shields, जो कि हमारी जो हबल टेलीस्कोप है उसको इफेक्ट नहीं करेगा, क्योंकि यहाँ पे जो स्टीयरिंग और व्हाट आई से जो सन शील्डिंग साइड है जो कि एक तरह से ये कवरिंग और प्रोटेक्ट करेगा. यहाँ पे कोई ऐसा इंस्ट्रूमेंट नहीं लगा हुआ है जो कि डैमेज हो सके थ्रू बिकॉज ऑफ सोलर रेडिएशन. देयर इज अ सेकेंडरी मिरर एज वेल. Here in this picture, there is a star tracker and there is an antenna for communication with the Earth, in the below you can see it's a below एक नीचे से पिक्चर ली हुई है हबल टेलीस्कोप की और सॉरी जेम्स वेब स्पेस टेलीस्कोप की और एक फ्रंट से ली हुई है. So there is one steering control as well, and there is antennas, star trackers, secondary mirrors, multiple layers of sun shields, science instrument. All these instruments are highly protected because of solar radiation and cosmic radiations. उनसे protect किया जाता है और primary mirror जो हैं कुछ इस तरह से लगे हुए हैं. This Hubble telescope, sorry, James Webb Telescope is going to be unfold very soon. और इसका launch period जो है, it will take at least 6 to 7 months to complete this whole time. हमारे पास जो first image आएगी जेम्स वेब स्पेस टेलीस्कोप से वो कोई 2 महीने बाद आएगी at least. और 6 महीने बाद जो है ये completely unfold होगी and fully unfold is going to be happen in July or August 2022 में जो है ये completely unfold हो जाएगी. For now, there is a method to communicate with James Webb Space Telescope. इसके लिए कोई हमें method की भी ज़रूरत है जिसके थ्रू हम इसको मालूम कर सकें कि किस तरह से जेम्स वेब टेलीस्कोप से कम्युनिकेट किया जाएगा. सो देयर इज़ अ स्टेशन विच इज़ स्पेस टेलीस्कोप साइंस इंस्टीट्यूट जो कि ये इंस्टीट्यूट जो है इस टेलीस्कोप से कम्युनिकेट करेगा. यहाँ पे रिसर्चर्स, साइंटिस्ट, एस्ट्रोनॉमर्स मौजूद हैं और जो इस पे काम कर रहे हैं और दे आर वर्किंग ऑन दिस होल बिग प्रोजेक्ट जो कि $billions प्रोजेक्ट है. इस पे काम कर रहे हैं. इसमें कोई 14 कंट्रीज इन्वॉल्व हैं जिसमें इटली, स्विट्ज़रलैंड, बेल्जियम, यूएस, यूरोपियन स्पेस एजेंसी भी इन्वॉल्व है, जैक्सा भी इन्वॉल्व है. सो देयर आर सो मेनी कंट्रीज इन्वॉल्व इन दिस होल मिशन and we are so excited to discover the universe, from early universe to galaxies over time, even the life cycle of the stars and the other worlds. And then let's see, ये हमारे पास कुछ आर्ट वर्क देखे गए हैं जो कि कुछ लोगों ने बनाए हैं जेम्स वेब टेलीस्कोप से इंस्पायर्ड होके. So maybe you can try to create some artwork like this. We will have this activity at Full Circle Gallery जिसमें हम लोग डिज़ाइन मॉडल्स बनाएंगे जेम्स वेब टेलीस्कोप का 3D डिज़ाइन मॉडल्स बनाएंगे थ्रू ओरिगामी आर्ट व्हाट आई से. और इन सारी चीज़ों के अलावा ये आर्टवर्क आप देख सकते हैं कि इसको आप ऑयल कलर के अलावा आप वाटर कलर के साथ भी काम कर सकते हैं और इससे इंस्पायर्ड कुछ आर्टवर्क बना सकते हैं. इस तरह के आर्टवर्क के बजाय आप आई रिकमेंड कि कुछ इस तरह का भी आर्टवर्क बना सकते हैं. इट्स नॉट रियली इंपॉर्टेंट कि आप जो है आर्ट इज़ ओपन फॉर ऑल. एनीवन कैन पेंट एनीथिंग व्हाटएवर दे अंडरस्टैंड थ्रू दिस वर्कशॉप या उनकी अंडरस्टैंडिंग जो स्पेस के बारे में हो दे कैन टॉक अबाउट इट एंड क्रिएट सम इंटरेस्टिंग आर्टवर्क. सो हियर वी हैव अनदर लास्ट मॉडल जिसमें आप लोग देख सकते हैं कि इट्स अ कलेक्शन ऑफ डिफरेंट स्पेस ऑब्जेक्ट, सेलेस्टियल ऑब्जेक्ट जिनको कहते हैं, उनसे इंस्पायर्ड आर्टवर्क बनाया है और उसको जेम्स वेब टेलीस्कोप की जो आइकॉनिक स्ट्रक्चर है उससे उसके थ्रू इसको कंपाइल किया हुआ है. सो दिस इज इट फॉर नाउ. आई वुड लाइक यू ऑल टू आस्क as many as question as you want. We have 30 minutes for all your questionnaires. You can raise your hand and ask me any question if you want to talk about anything that you would like to say, because हमारा 18th को जो आर्ट एग्जीबिशन होने वाला है उसमें हम लोग we want more and more artwork जिसमें आप लोग काफ़ी सारे आर्टवर्क बनाएं और हमें सबमिट करें जिसमें you can only paint solar system, you can also do some other art sort of artwork. आप लोग जो जिस तरह का आर्टवर्क बनाना चाहें यू कैन मेक एंड सबमिट इट टिल टुमारो और मे बी डे आफ्टर टुमारो इन द मॉर्निंग. दैट्स इट. इसके अलावा जो है हमारा आफ्टरनून के टाइम में ये क्लोज हो जाएगा और इवनिंग में 5 बजे जो है हमारी एग्जीबिशन स्टार्ट हो जाएगी. सो इफ़ यू वांट टू आस्क एनीथिंग, अगर आप लोगों का कोई सवाल हो, आई नो यू हैव अ लॉट ऑफ क्वेश्चंस, आप लोगों ने काफ़ी सारे मुझसे सवाल पूछे जिसका मैं टाइम टू टाइम जवाब नहीं दे सका क्योंकि हमारे पास देयर वर सो मेनी थिंग्स हैपनिंग. दिस वर्कशॉप वाज वेरी लॉन्ग, आई नो इट टुक अ लॉट ऑफ टाइम. सो 18 you can come and join us, even 17 tomorrow afternoon at 2 p.m. after you can join with us and do some art activity at Full Circle Gallery. Okay, इट्स ऑल योर चॉइस। आप लोग जिस तरह का भी आर्टवर्क बनाना चाहें आर्टवर्क बना सकते हैं और आप हम लोग को सबमिट कर सकते हैं। मतलब आर्टवर्क इंस्पायर्ड बाय स्पेस हो, जेम्स वेब टेलीस्कोप हो, हबल टेलीस्कोप हो, सोलर सिस्टम हो, यूनिवर्स हो, नेबुलाज हो, गैलेक्सीज हो, देयर आर सो मेनी थिंग्स इन स्पेस। यस, anyone would like to talk about, unmute themselves, yes, and say it। जी, अगर आप लोग का कोई सवाल हो प्लीज। I cannot see any question now. Sir, which type of picture like different या only solar system? Any type of. Okay, आप लोगों ने आज काफ़ी सारी यूनिवर्स को एक्सप्लोर किया है, not only solar system. So this was little intense. Yes. G, if you want to ask, you can ask me the question. You don't have to use any application. आप लोगों ने कोई application use नहीं करनी है. If you want, you can use digital tools as well. You can create your artwork. अगर आप लोगों ने digitally artwork भी create करना है तो आप लोग हम लोग को email कर सकते हैं और artwork को submit कर सकते हैं. I will send you another email with the details of कि हम लोग क्या क्या कर सकते हैं with this James Webb Space Telescope. और here is a link if you want to submit your artwork directly in our drive. हमारी Google Drive पे आप लोग directly submit कर दीजिए, so it will be much more easier to cover all your. So here, let me just enter the link over here. G, anyone? If anyone would like to raise their hand or unmute themselves, talk to me, say something, G, go for it.